Hello guys, my name is Prince and this is Smart Center. Subscribe to my YouTube channel for more videos. Post your comments and questions on my social media handles and I'll respond to it. We are beginning a new topic, number bases. What are the objectives that we look forward to achieving at the end of this topic? At the end of this topic, you should be able to convert numbers from other bases to base 10. You should be able to convert numbers from base 10 to other bases. You should be able to convert numbers between two non-decimal bases. You should be able to add, subtract, multiply, and divide non-decimal numbers. And you should be able to solve equations involving number bases. So let's begin by looking at what a number base is. So we use numbers in mathematics every day. Now usually the numbers that we write, they are in a certain system called the decimal system, and we write these numbers with the digits 0 to 9. So we use numbers every day, just as I said. And these numbers that we write them in decimal system with the digits 0 to 9. So if you check the numbers that you use, you can think of the numbers 2, 3, 4, 23, 25, 45. We use the digits 0 to 9 to write those numbers, and that is called the decimal system. The decimal system is also known as base 10. Now what you have to know is that there are other bases too. We can write these numbers in other bases. So for example, if you take the number, let's pick a random number. Let's say we pick the number 37. If you pick the number 37, sorry, I'm going to clean here and write 37 so that you get what I mean. Okay, so let's pick the number 37. 3 and 7. This is better. So if you pick the number 37, we can see that we got 37 from the digits 0 to 9. So 3 is within this range and 7 is also between this range. Now 37 here is written in base 10. That is the usual practice that we do. Base 10 is also known as the decimal system. What you have to know is that 37 here, which is in base 10, can also be written in other bases that are not base 10. So you can think of base 2, base 3, base 4, base 5, base 6, and it goes on and on and on. So these numbers here can also be written in other bases. So our main focus in this topic is that we are going to look at how to write numbers in other bases that are not base 10, or how to perform operations, that is addition, subtraction, multiplication, and division on numbers that are in other bases that are not base 10. So if you have numbers in other bases, how will you know? To indicate that a number is in a base other than base 10, a small subscript is written after the number. Now this is what we mean by a subscript. We can see from here that we have this number 36. Then a small number is written beneath 6 or underneath 6. So we can see that 3 and 6 here is in the base 7. So to indicate that a number is written in another base other than base 10, a small subscript is written after the number. So from here, if you have a number that is not in base 10 or in any other base, the base will be indicated after the number and to be written as a subscript. So it is written as a subscript after the number. So here the number that we have here is 36. Then we have it in base 7. So you write 36, then you write 7 as a subscript after 6. So 36 here means that the number 36 with the subscript 7 means that the number 36 is in base 7. Now you can see from here that when we wrote 37, we did not write any base here. Actually 37 is in base 10. But if you have a number in base 10, we don't indicate the subscript as 10. You can write it there, but whenever you see a number with no subscript, it means that that number is in base 10. So other examples are, we have the number 1101 in base 2. We have the number 514 in base 6. we have the number 332 in base 4. So when you see the subscript written after the number, the subscript gives you an indication of the base in which we are working. Now you need to take note of this very important thing. Whenever we are in base 2, we can only use two digits, the digits 0 and 1. 2, which is the base, is not included. Now if you watch this slide, you can see that in base 10, we use the digits 0 to 9 because 10 is the base that we are talking about, so 10 will not be included. So we use the digits 0 to 9 in base 10. So if you are in base 2, we are going to use the digits 0 and 2 because we are in base 2, so 2 will not be included. In the same way, so for some examples, if you want some numbers in base 2, we can have 10011 base 2, 10111 base 2, and 10 base 2. So you can see that all these numbers are in base 2, and we only use the digits 0 and 1 because we are working in base 2. If you have the in base 3, we use the digits 0, 1, 2 in base 3. So you don't add 3 since we are in base 3. So if you want some examples of base 3 numerals, you can have 102, 11 base 3. So what you learn from here is that you can't have 2 in base 2. In the same way, you can't also have 3 in base 3, but you can have 111 in base 3. So base 3 numerals consist of 0, 1, and 2. So whenever you are in base 3, the numbers must consist of these numerals. In base 4, you can also use 0, 1, 2, and 3. So what we are learning from this is that whenever you are in a particular base, that number cannot be included in the base. So whenever you are in base 4 cannot be a base 4. 4 can't be a numeral in base 4 since we are working in base 4. So examples of base 4 numerals are 10321 base 4, 1221 base 4, 13302 base 4. So because we are working in base 4 can't be part of the digits in base 4. So it continues. If you are working in base 5 can't be part. So in base 5, the digits you can use will be 0, 1, 2, 3, and 4. In the same way, in base 8, the digits you can use will be from 0 up to 7 in base 8. In the same way, if you are working in base 11, you use T to represent 10. So you can see that in base 11, the numerals will be from 0, the digits will be from 0 up to 10. Because we are in base 11, so the digits will be from 0 up to 10. Now, in base 11, we don't write 10 as 10. We use T to represent it. So whenever you have T in a base 10, in a base 11 numeral, T stands for 10. So 860 T1 base 11. The T here stands for 10. You don't write it as 10, but you write it as T. In the same way, if you have 175 TT4 base 11, this T here stands for 10. So this T is 10 and this T is also 10. We are going to use this a lot in subsequent videos, so take your time and understand this. In the same way, if you are in base 12, we use T to represent 10 and we use E, the letter E, to represent 11. So in base 12, we use T to represent 10 and we use the letter E to represent 11. So for example, you can have 523 E7 base 12. So E here stands for 11. In the same way, you can have ET4 base 12. E stands for 11 and T stands for 10 in base 12. For the sake of simplicity, we are not going to go beyond base 12 in this video and all the other videos. So the maximum base that you'll be considering in the videos that you'll be looking at will be base 12. So we'll be considering from base 2 up to base 12 in this video and the subsequent videos. Thank you so much for watching this video on introduction to number bases. Take your time and understand what we learned in this video. In the next video, we are going to see how we can convert a number from a given base to base 10. So let's say that we have a number in base 2. We are going to learn how we can convert a number from base 2 to base 10. not just base 2 but other bases. So you learn converting from other bases to base 10 in the next video. Bye bye. We are on the topic number bases, and this is the second video on number bases. In the previous video, we saw that in the usual operations of numbers that we perform, that is the addition, subtraction, multiplication and division of numbers that we perform, the numbers we handle are usually in base 10. But there are other bases other than base 10. In this video, we are going to see how to convert numbers from other bases to base 10. So let's pick some examples and see how this is done. We are being told to convert the following to base 10, and we have been given from I to VI. So you will take them one after the other and see how this is done. With the first example, we are being told to convert 11001 base 2 to base 10. So we are going to see how to do this. Now, whenever you are given a number in a different base to convert to base 10, the first thing you need to do is to multiply each digit in the number with the base. Now, this is what I mean. Multiply each digit with the number with the base. So you take the first digit or the first number here and you multiply it with the base. Then you close the bracket, you bring the addition sign. You take the next one, you multiply it with the base, as you can see here. You take the next one here, which is 0, you multiply it with the base, which is 2, as you can see here. You take the next one again, which is 0, you multiply it with the base. Then you take the next one, in this case, which is the last one, you multiply it with the base, as you have seen here. Now, after you have done with this, you have to indicate the order of the base multiplying each digit. I'm going to repeat what I said. You indicate the order of the base multiplying each digit. Now you can see from here that we have multiplied each digit with the base. Now the base multiplying each digit has an order. This is what I mean by an order. Remember from indices that we can write a number. For example, you can write 3 exponent 4. Now when you write 3 exponent 4, 3 is referred to as the base and 4 is referred to as the power or index. It's also referred to as the order. So in this case, the order of 3 is 4. The power of 3 is 4, or the index of 3 is 4. So what I mean by indicate the order of the base multiplying each digit is that the bases multiplying these digits, in this case, these 2, 2, 2, 2, and 2, each one of them has an order, a power, or in an index. So you have to indicate it. Now this is how it's done. Beginning from the right to the left, the order or power of the first base is 0. Then the next one is 1. The next is 2, 3, and 4. So after you've multiplied each digit with the base, what you have to do is that you indicate the order of the bases multiplying each digit. So beginning from right to left, the order of the first base is 0. Then you continue 1, 2, 3, 4. So it's going to continue up to the highest order possible. So in this case, the highest order possible is 4. So you have to end from at 4. So it always begins from 0 and it continue up to the highest order possible. Now you can see from here that the powers were given to the bases, not the digits. So remember that when giving the powers, give it to the base, not the digit or the number that is being multiplying it. So you continue with the simplification. So here we know that we are going to have 1 times 2 exponent 4. 2 exponent 4 is the same as 2 times 2 times 2 times 2, and we know that will give us 16. 1 times 2 exponent 3, 2 exponent 3 will give us 8. 0 times 2 exponent 2, 2 exponent 2 will give us 4. 0 times 2 exponent 1, 2 exponent 1 will give us 2. Then plus 1 times 2 exponent 0 is 1. If you watch the video on indices, you remember that any number or variable raised to the power 0 is 1. So 2 raised to the power 0 will give us 1. So we continue with the simplification. 1 times 16 will give us 16. 1 times 8 will give us 8. 0 times 4 will give us 0. 0 times 2 will give us 0. 1 times 1 will give us 1. So we have 16 plus 8 plus 0 plus 0 plus 1, and that is giving us 24. So if you convert, we can say that therefore 11001 base 2 is 25 in base 10. So in base 10, the number is 25, but if you convert it to base 2, it's 11001 base 2. So we can say therefore 11001 base 2 is equal to 25 base 10. Remember that 25 base 10 is the same as 25. You can write it without the base since it's already in base 10. Let's pick the next example. So we have 1121 base 5. So what you do from here is that first you multiply each of the digits with the base. So you multiply 1 with the base, which is 5. You multiply 2 with the base, which is 5. You multiply 2 with the base, which is 5. Then you multiply the last one, 1 with the base, which is 5. Then from here you order it. So the first one beginning from right is 0. The next one is 1. The next one is 2. Then the next is 3. So we come here, you have 1 times 5 exponent 3 is 125, plus 2 times 5 exponent 2 is 25, plus 2 times 5 exponent 1 is 5, plus 1 times 5 exponent 0 is 1. Remember that any number exponent 0 is 1. So 1 times 125 will give us 125, 2 times 25 will give us 50, 2 times 5 will give us 10, 1 times 1 will give us 1. So we add 125 to 50 to 10 to 1, and we are getting 186. So we can say that therefore 1221 base 5 will give us 186 base 10. So if you convert 1221 base 5 from base 5 to base 10, you are going to get 1860. So you see from here that it follows the same principles as we did in the first one. Let's take the next example. We have T181 base 12. Remember that in the first video we said when you write T in base 12, the T stands for 10. So from here it follows the same principle. Multiply each digit with the base. So we multiply T with the base, which is 12, then plus 1 with the base, which is 12, 8 with 12, then 1 with 12. Then you order. Remember that when you are ordering, you begin from right to left. So 0, 1, 2, then 3. So here the highest order possible is 3. So you end at 3. Now we continue. We know that T is the same as 10 in base 12. So T will give us 10 times 12 exponent 3 will give us 1728. You can do this on a calculator and you see that you are going to get 1728. Then plus 1 times 12 squared will give us 144, plus 8 times 12 exponent 1 will give us 12. Any number exponent 1 is the same number. Plus 1 times 12 exponent 0 will give us 1. Any number exponent 0 is 1. So you are going to have 10 times 1728. That will give us 17280, plus 1 times 144 will give us 144, plus 8 times 12 will give us 96, plus 1 times 1, which will give us 1. So we add all this and we are getting 17521. So what it means is that if you convert T181 base 12 to base 10, you are going to have 17521 base 10. Let's pick the next example. We have 1441 base 6, and we are supposed to convert this to base 10. So once again, you multiply each digit with the base. So you multiply 1 with 6, you multiply 4 with 6, you multiply 4 again with 6, then you multiply 1 with 6 as you see here. Then you order it beginning from right to left. So 0, 1, 2, 3. From here you continue with the simplification. So we have 1 times 6 exponent 3 is 216, plus 4 times 6 exponent 2 is 36, plus 4 times 6 exponent 1 is 6, plus 1 times 6 exponent 0 is 1. Any number raised to the power 0 is 1. So you are going to have 1 times 216 to give us 216, plus 4 times 36 to give us 144, plus 4 times 6 will give us 24, plus 1 times 1 will give us 1. So we have You add all this and you are going to get 135. So it means that if you convert 1441 base 6 to base 10, you are going to have 385 base 10. Now let's pick another example. In this example, we can see that we have a decimal point in it. So the procedure will be the same, just a slight difference. So you are going to see how to do that. Once again, you multiply every single digit in here with the base. So you multiply 1 by the base, so 1 times 2, then 1 times 2, 1 times 2 as we see here, 0 times 2, then 1 times 2 here. Now, because we have a decimal point here, we first have to order for the whole number part, then we order for the decimal part. So ordering for the whole number part, we know that the whole number part ends here, then this part is the decimal part. The decimal part are the 3 digits at the end, then the whole number part are the 2 digits at the beginning. So we first do for the whole number part. So ordering for the whole number part, we know that it's going to be 0, 1. So this is the whole number part. We have ordered for the whole number part here. Then from here you order for the decimal part. Now when you are ordering for the decimal part, you can see for the whole number part, we begin from right to left. So right 0, then we go here 1. When you are ordering for the decimal part, you begin from left to right, and the first one is going to be -1. Then the next one is going to be -2. Then the next one is going to be -3. So it will continue up to the highest order or the lowest order possible. So whenever you have a decimal part, don't forget that it follows the same principle. Multiply each digit with the base. Then you first order for the whole number part. So we are ordering for the whole number part. That will give us 0 and 1. Then you order for the decimal part. For the decimal part, you begin from left to right, and the first one is -1. The next one will be -2. Then the one that follows will be -3. From here, you continue with your simplification. You know that 1 times 2 exponent 1 will give us 2, plus 1 times 2 exponent 0 is 1, plus 1 times 2 exponent -1 is 0.5, plus 0 times 2 exponent -2 is 0.25, plus 1 times 2 exponent -3 is 0.125. So 1 times 2 will give us 2, 1 times 1 will give us 1, 1 times 0.5 will give us 0.5, 0 times 0.25 will give us 0, 1 times 0.125 will give us 0.125. So we add everything here, we are getting 3.625. So we can say that if you convert 1.101 base 2 to base 10, you get 3.625. Let's take another example. We have 133.02 base 4. So all that you need to do is to multiply each digit with the base. So you multiply 1 with the base, you multiply 3 with the base, you multiply 3 with the base again, you multiply 0 with the base, then you multiply 2 with the base. Now since we have a decimal point here, you have to order for the whole number part, then you order for the decimal part. You know that the whole number part will end here. The decimal part are the last 2 digits. So order for the whole number part. So we have 0, 1, 2. Then from here you order for the decimal part. The first one will be -1, then the next one will be -2. Then you continue with the simplification. So we have 1 times 2 exponent 4, which is 16, plus 3 times 4 exponent 1, which is 4, plus 3 times 4 exponent 0, which is 1, plus 0 times 4 exponent -1 give us 0.25, plus 2 times 4 exponent -2 give us 0.0625. 1 times 16 is 16, 3 times 4 is 12, 3 times 1 is 3, 0 times 0.25 will give us 0, plus 2 times 0.0625 will give us 0.125. We add everything here and we are getting 31.125. So it means that if you convert 133.02 base 4 to base 10, you are going to have 31.125. Thank you for watching this video. Pick more examples on how to convert numbers from other bases to base 10 and use the same principles that we have done in this video. Try your hands on these examples and you'll be conversant with them. See you in the next video where we will learn how to convert numbers from base 10 to other bases. Bye bye. We are on the topic number bases, and this is the third video on number bases. In the previous video, we learned how to convert numbers from other bases to base 10. In this video, we are going to learn how to convert numbers from base 10 to other bases. So let's pick some examples and see how this is done. Convert the following base 10 numerals to the base indicated. So we are to convert 100 to base 3. Then from there, we are also supposed to convert 1207 to base 5, 302 to base 2, then 1162 to base 7. So we are going to see how this is done. Let's pick the first one. We are converting 100 to base 3. Now whenever you are being given this a base 10 numeral to convert to base 3, you have to draw a table like what I've drawn here. So in the table, you first write, you draw a table with 3 columns here. So you have the first column, the second column, and the third column. The number of rows will be shown as we go on. So it will depend on how many divisions we are going to have. You understand that very soon. So don't worry about the rows, just worry about the columns. So we make a table of 3 columns. In the first column, the first column belongs to the base that you are converting the number to. So here we are converting 100 to base 3. So we are converting to base 3. So you write 3 here. Then the heading of the second column will be the number that you are converting. The number you are converting is 100. So you have that there. Then the last one will be the remainder. Now this is what we are going to do. The first step you have to do is to divide the number by the base. That is the first thing you do. So you divide 100 by 3. So you press on your calculator. We have 100 divided by 3. Now if you divide 100 by 3, you can see from here that you are getting 33.3333, which means that if you divide 100 by 3, you are going to have 33 as your whole number. Then there will be a remainder. That is why you have the decimal point here. So you first have to worry about the whole number. The whole number you are getting is 33. So you write that here as 33. Then you write the base that you are converting into it again here. Then you write, after you divided 100 by 3, you know that you are getting 33. But what is the remainder? The remainder will be 1. Now how do you know the remainder is 1? Multiply 3 by 33 and you see that you are getting 99. If you subtract that from 100, you are getting a remainder of 1, which means that if you divide 100 by 3, you are going to get 33 as your whole number, then a remainder of 1. I hope that is clear. So you write the whole number here, then you write the remainder here. Then the number you are converting it to is also here. So we do the same thing again. We divide 33 by 3. If you divide 33 by 3, you are going to have 11. You see, if you divide 33 by 3 on your calculator here, 33 by 3, you are having 11. This time there is no decimal point, which means that the remainder will be 0. So if you divide 33 by 3, you are getting 11. Then the remainder is 0. Now to see that the remainder is 0, you see if you multiply 3 by, I'm going to do this here for you to see. If you multiply 3 by 11, you are getting 33. You subtract it from the number on top of here, which is also 33, and the remainder is 0. I hope that's understandable. Then you move on. You divide 11 by 3 again. So if you divide 11 by 3, you see you are going to get 3. If you do that on your calculator, you are going to get 3 and a remainder of 2. To see that the remainder is 2, if you multiply 3 by 3, you are getting 9. If you subtract 9 from the number on top of it here, which is 11, 11 minus 9 will give us 2, which means that if you divide 11 by 3, you are getting 3 as a whole number, then a remainder of 2. Now you continue. This time divide 3 here by 3 again. If you divide 3 by 3, you are getting 1. 1 as a whole number and 0 as a remainder. Now from here you can see that the number here is 1. Then the numbers here are 3, 3, 3, 3. If you have the number in this column to be smaller than the number here, you write it as the last number in the remainder column here. So since 1 is smaller than 3, you write it as 1 here, and that is going to be the last number in the remainder column. So we are going to continue the division until the number in this column, in the second column, becomes smaller than the number in the first column. If the number in the second column becomes smaller than the number in the first column, then you write it here, and that is going to be the last row. Now, how do we find the converted value? So we are supposed to convert 100 to base 3. We are finished. How do we pick the numbers? The answer is what we have in the remainder here. That is what I've indicated with red. Remember, in an exam, you don't necessarily have to use a red pen here. I'm just using this to show you how to pick the answers. You pick the answers in this order. So you pick it as the arrow is showing. You pick it from down here up to the top here. So if you are converting 100 to base 3, the answer is the remainders, and you pick it from this side. So it's 0, 1, 0, 2, 0, 1. So we pick it in this order or in this manner. So 1, 0, 2, 0, 1. And funny enough, in this answer, if you pick it either this way or that way, you are getting it correct. 1, 0, 2, 0, 1 or 1, 0, 2, 0, 1. But this is how you pick it. You pick it from down here up to the top. So which means that if you are converting 100 from base 10 to base 3, our answer is 1, 0, 2, 0, 1. Let's pick another example. We are supposed to convert 1207 to base 5. So as I said, you draw a table of 3 columns. Don't worry about the number of rows. Worry about the column. The columns are 3. The heading of the first column is the base to which you are converting. The second one is the number. Then the third is the remainder. So once again, you divide 1207 by 5. So we are going to do that on the calculator, and you see what we are talking about. So 1207, you divide that by 5. And we are getting 241.4, which means that the whole number is 241, but there is a remainder. So you write 241 here. If you write 241 here, multiply 241 by 5. I'm teaching you how to find the remainder. So we multiply 241 by 5. 241 times 5. And we are getting 1205. So you see that if you multiply 241 by 5, you are getting 1205. If you subtract 1205 from 1207, you are getting 2. So 2 is the remainder. Then you move on to the next row. You divide 241 by 5. If you divide 241 by 5, we are getting 241 divided by 5. We are getting 48.2, which means that there's also a remainder. Since we have a decimal point here, so there's a remainder. So the whole number is 48. So we write 48 here. Now I'm going to show you how to find the remainder. Multiply 5 by 48. So 5 times 48, and we are getting 240. Subtract 240 from the number on top of it. So 241 minus 240, and you will see that the remainder is 1. I hope it's clear now. The next one, divide 48 by 5. So 48 divided by 5 divided by 5, and we are getting 9.6. So the whole number is 9.6. It's 9. So you write 9 here. If you want to find the remainder, multiply 9 by 5, and 9 times 5 will give us 45. You subtract 45 from the number on top of it, which is 48, and that will give us a remainder of 3. The next one, you divide 9 by 5. You divide 9 by 5, and we are getting 1. as the whole number. So 1 is the whole number, then a remainder of 4. Since 5 times 1 will give us 5, 5 minus 9 will give us 4, so a remainder of 4. Now you can see that the number in this column here is now less than the number here. 1 is less than 5, so you write it here at the final element here. So you write it here. So this time you pick the order, you pick the answer in this manner. So 1 4 3 1 2. So it means that if you convert 1207 to base 5, you are going to have 14312 base 5. So 1207 base 10 is equal to 14312 base 5. Let's pick another example. We have 302, and you are supposed to convert that to base 2. So you do your table of 3 columns here. So we have 2, 302, and the remainder that we are going to get. So the first thing that we need to do is to divide 302 by 2 on our calculator. So 302 divided by 2, and that is give us 151. So it means that it's giving us 151 as a whole number without a remainder. So 151 as a whole number, the remainder is 0. If you want to try and see if the remainder is 0, you multiply 2 by 151 and we are getting 302. You subtract it from 302, you are getting 0. You move on to the next one. You divide 151 by 2. So 151 divided by 2, and that will give us 75.5. So the whole number part is 75. So 75, then it will give us a remainder of 1, because if you multiply 2 by 75, you get 150. You subtract 150 from 151 and we are getting a remainder of 1. Next, you divide 75 by 2. If you divide 75 by 2, you are getting 37 as the whole number, then a remainder of 1. If you want to, so if you divide, you are going to get 37 as the whole number. You multiply 2 by 37, you are going to get 74. You subtract that from 75 and you are getting 1 as the remainder. Next, you divide 37 by 2. So 37 by 2 will give us 18 as the whole number, a remainder of 1. 2 times 18 will give us 36. You subtract 36 from 37 and you are getting 1 as the remainder. Next, you divide 18 by 2. 18 divided by 2 will give us 9 and 0 as the remainder, because 9 times 2 will give us 18. 18 minus 18 will give us 0. Next, you divide 9 by 2. So 9 divided by 2 will give us 4. 4 times 2 will give us 8. 8 minus 9 will give us 1 as the remainder. Next, we divide 4 by 2. 4 divided by 2 give us 2, remainder 0. I hope that's simple. Next, we divide 2 by 2. 2 divided by 2 will give us 1, remainder 0. Now you can see that the number in this column here is now less than the number here. So we are going to write it here as the last number. So in picking our answer, we pick it in this way. So you have 1001 0110. So 1001 0110 base 2, which means that if you convert 302 base 10 to base 2, you are going to have 100101110 base 2. Let's pick the last example. You are supposed to convert 1162 to base 7. So this is what you have to do. First, you divide 1162 by 7 on your calculator. So 1162 by 7, and that will give us 11166. So you see, it's giving us 166 without a remainder. So it means that we have 166 as the whole number, remainder 0. Next, we divide 166 by 7. So 166 divided by 7, and that will give us 32 points. We have some decimals. We are interested in the whole number here, so we pick the whole number as, sorry, we had 23, not 32. So 23 as the whole number. So we have that as our whole number. Now we need to find the remainder. In finding the remainder, multiply 7 by 23, which is the whole number. So 7 by 23. And we see that we are having 161. So we subtract 161 from 166. So 161, if you subtract 161 from 166, you know that we are having a remainder of 5. Because 166 minus 161 give us 5. Next, we divide 23 by 7. 23 divided by 7 will give us 3 as the whole number and a remainder of 2, because 7 times 3 will give us 21. 23 minus 21 will give us a remainder of 2. Now we can see that the number in this column here is 3 and the one here is 7. So what we have here is smaller than what we have here. So you write it as the last number here. So you have 3250. So in picking the numbers, you pick it as 3250. You pick it in this manner. Remember that in an examination, you don't have to bring the arrow here. You don't have to also write this one in red. I'm just using it to explain that these are the answers and this is how we pick them. So we have 3250 base 7. So if you convert 1162 base 10 to base 7, you will have 3250 base 7. Thank you for watching this video. Pick more examples on converting numbers from base 10 to other bases, and use the same principles that we used in this video and try your hands on those examples. See you in the next video, where you will learn how to convert numbers from one base to another base other than base 10. So in this case, the conversion will not be between a base 10 numeral and another base, but rather two numerals that are not in base 10. Bye bye. We are on the topic number bases, and this is the fourth video on number bases. In the second video, we learned how to convert numbers from other bases to base 10. In the third video, we learned how to convert numbers from base 10 to other bases. In this video, we are going to learn how to convert numbers between two non-decimal bases, that is, between two bases that are not base 10. So conversion between two non-decimal bases. Remember, we said that a decimal base means base 10. So in this video, we are going to learn how to convert numbers from one base to another base that are not base 10. So to convert a number from one non-decimal base to another non-decimal base, the first thing you need to do is that first convert the number to base 10. Then convert the number from base 10 to the required base. Now let's pick some examples to understand what this means. So you are supposed to convert the following. So you are converting 11001 base 2 to base 8. 441 base 5 to base 6. 43 base 5 to base 2. Then 307 base 8 to base 5. So this is what we do. You pick the first one, convert 111001 base 2 to base 8. The first thing we need to do is to first convert this number here, 111001 base 2. You convert it to base 10. Then you convert our answer from base 10 to base 8. So that is what we are going to do. First, you convert 111001 base 2 to base 10. So you're converting this one to base 2. If you watch the second video, we said that you multiply each digit with the base. So you multiply each digit with the base, as you can see from here. Then we order them. So you order it 0, 1, 2, 3, 4, 5. I hope that by this time you have picked a lot of examples on this, so you are conversant with what we are doing here. So 1 times 2 exponent 5 will give us 32. 1 times 2 exponent 4 will give us 16. 1 times 2 exponent 3 will give us 8. 0 times 2 exponent 4. 2 exponent 2 will give us 4. 0 times 2 exponent 1 will give us 2. 1 times 2 exponent 0 will give us 1. So this will give us 32. This will give us 16. 1 times 8 will give us 8. 0 times 4 will give us 4. 0 times 2 will give us 0 times 4 will give us 0. 0 times 2 will give us 0, 1 times 1 will give us 1. So we add everything here and we are getting 57. So you can see from here that we have converted 111,001 base 2 to base 10. So we have now converted this to base 10, but the question is telling us to convert it to base 8. So this time we convert this answer here, 57, we will convert it from base 10 to base 8. So we convert 57 base 10 to base 8. You know that if you are converting this to base 8, you draw your table like this, your 3-column table here. Then, you divide 57 by 8. So 57 divided by 8. That will give us 7 as our whole number here. So we write 7 here. Then, if you want the remainder, you know that 8 times 7 will give us 56. So 8 times 7 will give us 56. 8 times 7 will give us 56. Then you subtract 56 from 57 and we are getting a remainder of 1. Now we can see from here that the number here is 7. The one here is 8. It is less than this, so you are going to write it here. So we have now converted 57 to base 8, and in picking it, we know that we pick it in this manner, so we pick the answer as 71. So if you convert 57 from base 10 to base 8, you get 71. Now remember that we had 111,001 base 2, and we converted that to 57. Now we have converted 57 to base 8, which means that we can say that 111,001 base 2 is now 57 base 8. So you can see we have converted this number from base 2 to base 8. So to convert it, first convert this number here, 111,001 base 2, convert it to base 10. Then you convert your answer from base 10 to the base that you are given. So in this time you are given base 8, so you convert it from base 10 to base 8 as you have seen here. Let's pick the next example. We are converting 441 base 5 to base 6. So the first thing we need to do is to first convert 441 base 5 to base 10. So in converting that, we multiply 4 by 5, 4 by 5, then 1 by 5. Then you order the bases, so 0, 1, 2. So we multiply, we have 2 times 5 squared is 25. 4 times 5 raised to the power 1 is 5, plus 1 times 5 raised to the power 0 is 1. 4 times 25 will give us 100. 4 times 5 will give us 20. 1 times 1 will give us 1. You add them, you are getting 121. So if you convert 441 base 5 to base 10, you are going to have 121 base 10. Now you convert 121 to base 6, since the question is telling us to convert it to base 6, not base 10. If it had been to convert to base 10, then this will be our final answer. But he's saying that we should convert it to base 6. So we convert 121 to base 6. So you know that in converting 121 to base 6, you draw your table, you divide 121 by 6, and you are getting 20 points. So we are not worried about the decimal point. What we are worried about is the whole number. So we are having 20 whole number. The remainder is going to be 1. Since 6 times 20 will give us 120, then 120 minus 120, 121 minus 120 will give us 1 as the remainder. You divide 20 by 6, you are going to get 3 as the whole number and a remainder of 2. Since 6 times 3 will give us 18, 20 minus 18 will give us 2. Now the number here is smaller than the one here, so we write it as the last number here. So in picking this answer, we pick it as 321. So if you convert 121 base 10 to 3 to base 6, you are going to have 321 base 6. So we can now say that we have converted 441 base 5 to base 6, which is 321 base 6. Let's pick the next example. We are converting 43 base 5 to base 2. So what you have to do is now convert this base 5 numeral to base 10. So in converting it to base 10, you are going to have 4 times 5 plus 3 times 5. Then you order the bases, so 0, 1. So we have 4 times 5 exponent 1 is 5 plus 3 times 5 exponent 0 is 1. So 4 times 3 will give us 20. Sorry, 4 times 5 will give us 20. 3 times 1 will give us 3. You add them, you are going to get 23. So we can say that 43 base 5 is now 23. So you can see it's the same thing that we have been doing. So we keep on doing the same thing, we change nothing. Now we convert 23 to base 2. So in converting 23 to base 2, what you have to do is first divide 23 by 2. You will get a whole number of 11. The remainder is 2. Since 2 times 11 will give us 22. 23 minus 22 will give us 1. Next, you divide 11 by 2. Divide 11 by 2, you are going to get 11 divided by 2 will be 10. So it means that you are going to have a whole 11 divided by 2 give us 5 as the whole number. So 5 will be the whole number. You multiply 5 by 2, you are going to get 10. You subtract 11 minus 10 will give us 1 as the remainder. You divide 5 by 2, you are going to get 2 as the whole number and a remainder of 1. Since 2 times 2 give us 4, 5 minus 4 will give us 1 as the remainder. You divide 2 by 2, you are getting 1 as the whole number and a remainder of 0. Since 1 is smaller than 2, you write it 1 here. So you are going to have 1 0 1 1 1. So if you convert 23 to base 2, it's going to give you 1 0 1 1 1 base 2. Which means that if you convert 43 base 5 to base 2, you are going to get 1 0 1 1 1 base 2. Let's pick the last example. We are converting 307 base 8 to base 5. So the first thing we need to do is to convert 307 base 8 to base 10. So in converting it to base 10, we have 3 times 8 plus 0 times 8 plus 7 times 8. Then you order the bases. So we have 0, 1, 2. So you are going to have 3 times 8 squared will give us 64 plus 0 times 8 exponent 1 will give us 8 plus 7 times 8 exponent 0 will give us 1. So we have 3 times 64 to give us 192. 0 times 8 will give us 0. 7 times 1 will give us 7. You add everything here and we are getting 199. So if you convert 307 base 8 to base 10, you have 119. But we don't want our answer in base 10. We want it in base 5. So you convert 119 to base 5. If you are converting 119 to base 5, you draw your table as usual. You divide 199 by 5 and you are getting 39. So the remainder will give us 4. By this time, you should be conversant with how to find the remainder. Then you divide 39 by 5. You are getting a whole number of 7. The remainder is 4. Since 5 times 7 will give us 35. 39 minus 35 will give us 4. You divide 7 by 5. The whole number is 2. The remainder will give us 2. The whole number is 1. The remainder is 2. Now since 1 is smaller than 5, we write 1 here. So in picking our answer is 1 2 4 4. So if you convert 119 base 10 to base 5, you have 1 2 4 4 base 5. So we can say that if you are converting 307 base 8 to base 5, you are going to have 1 2 4 4 base 5. Thank you for watching this video on conversion between two non-decimal bases. Pick more examples on this and try your hands on it using the principles that you have learned in this video. In the next video, we are going to learn how to order numbers that are not in base 10. That is, arrange numbers that are not in base 10 in ascending or descending order. Bye bye. We are on the topic number bases. In the previous video, we learned how to convert numbers between two non-decimal bases. In this video, we are going to learn how to order numbers written in non-decimal bases. That is, arranging numbers in either ascending or descending order. By this time, the numbers will not be written in base 10. So to arrange numbers written in non-decimal basis in ascending or descending order, the first thing you need to do is convert all the numbers to the same base. Now, since you are comfortable with handling numbers in base 10, it is always advisable to convert the numbers to base 10. Then from there, compare their magnitudes and arrange them in the order required. So after you've converted all the numbers in base 10, you can now easily recognize which one is the biggest or which one is the smallest. So you can arrange them depending on their magnitude. That is how big or small the numbers are. So let's pick some examples and see how this is done. We are being told to arrange the following in ascending order of magnitude. So in this case, you are arranging in descending order of magnitude. So in descending order of magnitude, which means that we are arranging it from the smallest to the biggest to the highest. So in descending order of magnitude, we are arranging it from the biggest. In descending order of magnitude, it means that we are arranging it from the biggest to the smallest. So we are descending, so from the biggest to the smallest. So what we have to do is that, let's pick the first example and see how this is done. So we are supposed to arrange this from the biggest to the smallest, that is descending order of magnitude. So the first thing we need to do is to convert each one of them to the same base. As I said, it is always advisable to convert it to base 10 since we are comfortable handling base 10 numerals. So convert the first number here to base 10. So you convert 4415 to base 10. Converting this to base 10, we have 4 times 5 exponent 2 plus 4 times 5 exponent 1 plus 1 times 5 exponent 0. By this time, you should be comfortable with converting numbers to base 10. So we have 4 times 25 plus 4 times 5 plus 1 times 1. It's 4 times 25 will give us 100, 4 times 5 will give us 20, 1 times 1 will give us 1. We add everything here and we are getting 121. So we can say that 4415 will give us 121 in base 10. Next, you convert 4023 to base 10. So in converting it to base 10, we are going to have, so we multiply each digit with the base. So 4 times 6, 0 times 6, 2 times 1, 3 times 2 times 6, 3 times 6. Then you order the bases. So 0, 1, 2, 3. 4 times 6 exponent 3 will give us 216. 0 times 6 exponent 2 will give us 36. 2 times 6 exponent 1 will give us 6 plus 3 times 6 exponent 0 will give us 1. 4 times 216 will give us 864. 0 times 36 will give us 0. 2 times 6 will give us 12. 3 times 1 will give us 3. You add everything here and we are going to get 879, which means that if you convert 4023 base 6 to base 10, you are going to have 879. The next is to convert the next number, which is 1811 base 12. So you are converting this to base 10. You multiply every digit with the base. So 1 times 12, 8 times 12, 1 times 12, then 1 times 12. Then you order the bases. So 0, 1, 2, 3. 1 times 12 exponent 3 will give us 1728 plus 1 times 114, which since 12 squared will give us 144. 1 times 12 exponent 1 will give us 12 plus 1 times 12 exponent 0 will give us 1. Any number raised to the power 0 is 1. 1 times 1728 will give us 1728 plus 8 times 144 will give us 1152 plus 1 times 12 will give us 12. 1 times 1 will give us 1. You add everything here and we are getting 2893. So which means that if you convert 1811 base 12 to base 10, you are going to have 2893. Now we have converted all the numbers to base 10. So we have converted 441 base 5 to base 10. We had 121. We converted 4023 base 6 to base 10. We had 879. We converted 1811 base 12 to base 10, and we had 2893. We are supposed to arrange this in descending order, which means that from the biggest to the highest. From here, it's so clear that this is the biggest. So if you are comparing the base 10 numerals, you see that this is the biggest, followed by this, then followed by this. So we can see that this one here is the biggest. 1811 base 12 is the biggest. Then the next is 4023. Then the last is 4415, which is the smallest. Remember, if you are supposed to arrange this in ascending order will be from the smallest to the highest. So in that case, this will be the first, this will be the second, and this will be the third. But since it's in descending order, it's the other way around. So this is the first, this is the second, and that is the third. Let's pick another example. You are supposed to convert 415 base 6, 3321 base 4, and 1111 base 2 in descending order. So what you have to do now is to first convert all of them to base 10. So we pick the first one, 415 base 6. You convert it to base 10. You know that in converting, you are going to have, you multiply every digit there with the base. So 4 times 6, 1 times 6, and 5 times 6. Then you order them as you have seen here, 0, 1, 2. So in the multiplication, we have 4 times 6 squared is 36. 1 times 6 exponent 1 is 6, plus 5 times 6 exponent 0 is 1. So we have 4 times 36 to give us 144. 1 times 6 will give us 6. 5 times 1 will give us 5. You add everything, we are getting 155. So if you convert 415 base 6 to base 10, we have 155. The next is to convert 3321 base 4 to base 10. So in converting, we are going to have 3 times 4 exponent 3 plus 3 times 4 exponent 2 plus 2 times 4 exponent 1 plus 1 times 4 exponent 0. So if you do the multiplication, we have 3 times 64 plus 3 times 16 plus 2 times 4 plus 1 times 1. You do the multiplication here, you are going to have 192 plus 48 plus 8 plus 1. You add everything here, we are getting 249. So which means that if you convert 3321 base 4 to 249, you are getting 3321 base 4 to base 10. We are getting 249 base 10. So next you convert 1111 base 2 to base 10. So we multiply every digit with the base. So 1 times 2, 1 times 2, 1 times 2, 1 times 2, and 1 times 2. Then you order them as you have seen here. So 0, 1, 2, 3, 4. 2 exponent 4 is 16. 2 exponent 3 is 8. 2 exponent 2 is 4. 2 exponent 1 is 2. Then 2 exponent 0 is 1. So we are having 16 plus 8 plus 4 plus 2 plus 1. You add everything, we are getting 31. So which means that 11111 base 2 will give us 31 in base 10. So we have now converted all of them to base 10. So 415 base 6 will give us 115. 3321 base 4 will give us 249. Then 11111 base 2 will give us 36. So in arranging them in descending order, remember from the biggest to the highest, we know that this is the biggest, followed by this, then this is the smallest. So we have 3321 as the biggest, 3321 base 4 as the biggest, 415 base 6 as the next, then the smallest will be 1111 base 2. Let's pick the last example. We have 333 base 4, 444 base 5, and 222 base 4. So we are supposed to arrange this in descending order. So let's first convert the first one to base 10. So in converting 333 base 4 to base 10, we have 3 times 4 squared plus 3 times 4 exponent 1 plus 3 times 4 exponent 0. That is going to give us 3 times 16 plus 3 times 4 plus 3 times 1. 3 times 16 will give us 48 plus 3 times 3 times 4 will give us 12 plus 3 times 1 will give us 3. You add everything, we are going to get 64. So if you convert 3 base 4 to base 10, we are going to have 63. You add everything here, you are getting 63. So if you convert 3 base 4 to base 10, you are having 63. Next, you convert 4 base 5 to base 10. That will give us 4 times 5 squared plus 4 times 5 exponent 1 plus 4 times 5 exponent 0. You are going to have 4 times 25 plus 4 times 5 plus 4 times 1. 4 times 5 is 100. 4 times 25 is 100. 4 times 5 is 20. 4 times 1 is 4. You add everything, we are getting 124. So if you convert 4 base 5 to base 10, you are having 124. Now, you convert the last one, which is 2 base 4 to base 10, and we know that will give us 2 times 4 squared plus 2 times 4 exponent 1 plus 2 times 4 exponent 0. Now, this will give us 2 times 16 plus 2 times 4 plus 2 times 1. 2 times 16 is 32, 2 times 4 is 8, 2 times 1 is 2. You add everything there, we are getting 42, which means that if you convert 2 base 4 to base 10, that will give us 42. So we have seen that we have now converted all the numbers to base 10. So 3 base 4 in base 10. In base 10 is 63. 4 base 5 in base 10 is 124. 2 base 4 in base 10 is 42. So in arranging them in descending order, you know this one is the biggest one, so 4 base 5, followed by 3 base 4, then the next is 2 base 4. Thank you for watching this video. Pick more examples on ordering numbers in non-decimal basis and try your hands on them. See you in the next video, where we will learn how to add and subtract numbers that are not in base 10. Bye bye. Welcome back. We are on the topic number basis. In the previous video, we learned how to order numbers written in non-decimal basis. In this video, we are going to learn how to add and subtract numbers written in non-decimal basis. We have 4 questions here, and we are going to solve them one after the other. We will begin with the first one. Evaluate 11110 base 2 plus 1011 base 2. So we are going to add these two numbers that are in base 2. One thing you have to note is that addition and subtraction of numbers in non-decimal basis follow the same principles as addition and subtraction of numbers in base 10. What this means is that numbers that are not in base 10 are added and subtracted in the same way as numbers that are in base 10. When we are adding numbers in base 10, we usually write the one with the highest digit on top and the one with the lowest digit below. In this question, the first number has 1, 2, 3, 4, 5. So the first number has 5 digits and the second number has 4 digits. So we write the first number on top and the second number below. This is what I mean. Let's say that we are told to add 19 and 1421 in base 10. So we have 19 plus 1421 in base 10. We usually write the one with the highest digit on top. So we write 1421 on top, then we write 19 below, then we will have our addition sign. This is what we usually do. As I said, addition and subtraction of numbers in bases that are not base 10 is done in the same way as addition or subtraction of numbers in base 10. So we will do the same thing here. The first number has 5 digits, so we write that one first. The second number has 4 digits, so we write that one below. So we have 1 1 1 1 0 base 2 and 1 0 1 1 base 2. We will bring our addition sign. I'll bring these two lines so that we write our answers between them. There is one thing that you have to remember. We have learnt that in base 2, we can use only 2 digits. The digits we can use in base 2 are 0 and 1. So because we are working in base 2, we can use only 0 and 1. The addition that we have here is in base 10. In base 10, we can use the digits 0 to 9. But what we have here is in base 2, so we can use only 0 and 1. Now let's begin with our addition. So we have 0 plus 1. 0 plus 1 will give us 1. 1 in base 2 is 1. Let's move on to the next one. We have 1 plus 1. 1 plus 1 will give us 2. But because we are working in base 2, we can only use the digits 0 and 1. So we will have to find 2 in base 2. To help us understand that, let's consider the addition in base 10 that we have here. We have 1421 plus 19. This addition is in base 10. We will add 1 to 9. 1 plus 9 will give us 10. Because we are working in base 10, we can't write all the 10 here, so we will have to find 10 in base 10. To find 10 in base 10, we will divide 10 by 10. When we divide 10 by 10, we are going to have 1 remainder 0. So we write the remainder 0 here and carry 1 forward to the side. That is the same thing we are going to do here. 1 plus 1 will give us 2. But because we are working in base 2, we can't write all the 2 here. So we will find 2 in base 2. To find 2 in base 2, we will divide 2 by 2. 2 divided by 2 will give us 1 remainder 0. So we write the remainder 0 here and then carry 1 forward to this side. When we carry 1 forward to this side, we will have 1 plus 1. 1 plus 1 will give us 2. So here is now 2. Now 2 plus 0 will give us 2 again. As we have seen, 2 in base 2 is 1 remainder 0. So you write the remainder 0 here and carry the 1 forward to this side. When you carry it to this side, we will have 1 plus 1. 1 plus 1 will give us 2. So here is now 2. 2 plus 1 will give us 3. So we will find 3 in base 2. To find 3 in base 2, you divide 3 by 2. That will give us 1 remainder 1. So you write 1 here, then you carry the remainder 1 to this side. That will give us 1 plus 1. 1 plus 1 is 2. There is no number here, so it means the number there is 0. So you have 2 plus 0. 2 plus 0 will give us 1 remainder 0. So you write 1 remainder 0. Don't forget to indicate that our addition is in base 2. So as you can see, the addition in base 2 follows the same principle as addition in base 10. Our calculator allows us to add and subtract numbers in base 2. So I'm going to show you how you can use your calculator to add these two numbers that are in base 2. To do that, switch on your calculator. Then press on mode. When you press on mode, you have about 8 options on your screen. The fourth one is base, so select the fourth one. So you press on 4. When you press on 4, you will see DEC, that is DEC, and 0 beneath it. Dec means that your calculator is now in the decimal mode or the base 10 mode. We want our calculator to be in the base 2 mode. The base 2 mode is the binary mode. Now, click on the button with log on it. On top of the log button, you will see BIN. That is the short form for binary or base 2. So you click on that button. When you click on that button, your calculator will change from base 10, that is the decimal mode, to base 2, that is the binary mode. We can now enter the question we have here. So we have 1, 1, 1, 1, 0 plus 1, 0, 1, 1. After that, we will press equal to. We will pick our answer from the first significant figure. The first significant figure here is 1. So that is where we will start our answer from. So we have 1, 0, 1, 0, 0, 1, just as our calculation gave us. So let me go over it again. You click on mode, you select the fourth option, then you click on the log button to change your calculator from base 10 to base 2. Then you enter the question. The question here is 1, 1, 1, 1, 0 plus 1, 0, 1, 1. You click on equal to, then you start writing your answer from the first significant figure. Here, the first significant figure is 1, so our answer is 1, 0, 1, 0, 0, 1, base 2. Let's consider the next question. We have 213 base 4 plus 1111 base 4. So we write the one with the highest digit first. The one with the highest digit is the second number. So we have 1111 base 4. Then the next one is 213 base 4. We bring the addition sign. Then I'll bring our two lines so that you can write the answers between them. Let's begin with our addition. We have 1 plus 3. 1 plus 3 will give us 4. 4 in base 4 is 1 remainder 0, because 4 divided by 4 will give us 1 remainder 0. So you write the remainder 0, then you carry 1 forward to this side. You carry 1 forward to this side, you have 1 plus 1. 1 plus 1 will give us 2. 2 plus 1 will give us 3. Because we are working in base 4, we can write 3, because in base 4, the digits we can use are 0, 1, 2, and 3. So in base 4, we can use the digit 3. Let's continue. 1 plus 2 will give us 3. 3 in base 4 is 3. We don't have any number here, so 1 plus 0 give us 1. 1 in base 4 is 1. Then we indicate that we are working in base 4. Let's move on to the next question. We have 1, 1, 0, 1, 1 base 2 minus 1, 0, 1 base 2. So you write the one with the highest digit first, then the one with the smallest digit underneath it. You bring your negative sign, then I'll bring our two lines so that we can write our answers between them. Once again, it follows the same principles as subtraction in base 10. So let's begin. 1 minus 1 will give us 0. We are working in base 2, so we can use 0 and 1. Those are the only digits that we can use in base 2. 1 minus 1 will give us 0. 1 minus 0 will give us 1. 1 in base 2 is 1. Now let's come here. 0 minus 1 will give us negative 1. But we have learned in subtraction in base 10 that we can't write a negative number here. So we will have to come and borrow 1 from this side to this side so that we can do the subtraction. Now, to understand how this is done properly, let's consider an example in base 10. Let's say that we have this subtraction here in base 10. We are subtracting 19 from 1421. So we have 1421 minus 19. This subtraction is in base 10. We are very familiar with that. So let's learn how to do it. I'm going to draw the line here so that we can write our answers. Now we have 1 minus 9. 1 minus 9 will give us negative 8. But we can't write negative 8 here. So we will borrow 1 from this side to this side. Now, when we borrow 1 from this side to this side, so we borrow 1 from here to this side. Remember that our subtraction is in base 10. So this number 1421 is in base 10. 19 is also in base 10. And we have borrowed 1 from this side to this side. Because we are working in base 10, when we borrow 1, the value of that 1 is 10. So here, when we borrow 1 from this side to this side, the value of that 1 is 10. So here, the one that we have borrowed from this side to this side carries a value of 10. So we will add that 10 to 1 and we will get 11. We will now have 11 minus 9, and that will give us 2. So here we have 11 minus 9, and that will give us 2. We will be left with 1 here. 1 minus 1 will give us 0. 4 minus 0 will give us 4. And 1 minus 0 will give us 1. And this, we have our answer in base 10. Now, as you can see, because we are working in base 10, the one that we borrowed from this side to this side carried a value of 10. We are going to apply the same principle here. We have started our subtraction here already. 1 minus 1, we had 0. 1 minus 0, we had 1. Now here, 0 minus 1 will give us negative 1. As we can see from here, we can't write a negative number here. So we will have to come and borrow 1 from this side to this side. So we are going to borrow 1 from this side here to this side. Now look at something. Because we are working in base 2, when we borrow 1 from this side to this side, the value of that 1 is 2. Here, we were working in base 10. So when we borrowed 1 from this side to this side, the value of that 1 was 10. Here, our subtraction is in base 2. So when we borrow 1 from this side to this side, the value of that 1 is 2. So it means that when we borrow 1 from this side to this side, the value of that 1 is 2. So we will add that 2 to what we have here already, which is 0. 2 plus 0 will give us 2. And 2 minus 1 will give us 1. Here was 1, and we borrowed it to this side, so it is now 0. 0 minus 0 here will give us 0. Now we have 1 here, so 1 minus 0. We don't have any number here, so it means it's 0. So 1 minus 0 will give us 1. Don't forget that we are working in base 2. So it means that when we are working in base 2 and you borrow 1 from one side to another, the value of that 1 is 2. When you are working in base 3, the value of that 1 is 3. When you are working in base 4, the value of that 1 is 4. And it goes on and on. As I have already indicated, our calculator allows us to add and subtract numbers in base 2. So we can use our calculator to perform this operation. To do that, you switch on your calculator, then you press on mode. You select the fourth option, which is the base. So you click on 4, Then you change the calculator from base 10, that is the decimal base, to base 2, that is the binary base, by clicking on the button with log on it. So when you do that, the calculator changes from base 10 to base 2. We can now enter our question here. So we have 1, 1, 0, 1, 1 minus 1, 0, 1. You click on equal to, then we start writing our answer from the first significant figure. The first significant figure here is 1. So we have 1, 0, 1, 1, 0, base 2, just as we have here. I'll go over it again. You switch on your calculator, you click on mode, you select the fourth option, then you change your calculator from base 10 to base 2 by clicking on the log button. You enter the question that we have here. So 1, 1, 0, 1, 1 minus 1, 0, 1. You click on equal to, and you start writing your answer from the first significant figure. The first significant figure here is 1. So we have 1, 0, 1, 1, 0, base 2. Let's look at the last example. We have 2, 1, 2, base 5 minus 1, 3, 1, base 5. Here they all have the same digits. So we write the highest number first, then we write the least number beneath it. They are all in base 5. So 215 is the highest number and 131 is the least number. So we have 215 minus 131 base 5. Let's begin with our subtraction. Remember that we are working in base 5. So the digits we can use are 0, 1, 2, 3, and 4. And because we are working in base 5, when we borrow 1 from one side to another, the value of that 1 is 5. Okay, let's start. 2 minus 1 will give us 1. 1 in base 5 is 1. When we come here, we have 1 minus 3. 1 minus 3 will give us negative 2. We can't write negative 2 here. So you have to borrow 1 from this side to this side. So we are going to borrow 1 from here to this side. Now, because we are working in base 5, when we borrow 1 from this side to this side, it carries a value of 5. So we will add that 5 to what we have here already, which is 1. 5 plus 1 will give us 6. So now you have 6 minus 3. 6 minus 3 will give us 3. Here used to be 2. We borrowed 1 from this side to this side. So we are left with 1 here. 1 minus 1 will give us 0. Since 0 here will be the first number, it means that it is not significant. So we are not going to write that 0. So it means that our answer is 31 base 5. So 215 base 5 minus 131 base 5 will give us 31 base 5. Thank you for watching this video. Pick more examples and try your hands on them. In the next video, we are going to solve another question on adding and subtracting numbers in non-decimal basis. But this time, the two numbers we will be adding or subtracting do not have the same base. So for example, one number will be in base 3 and the other will be in base 5. In the next video, we are going to learn how to do that. Bye-bye. We are on the topic number basis. In the previous video, we learned how to add and subtract numbers that are in non-decimal basis. In this video, we are going to take yet another example on addition of numbers in non-decimal basis. But this time, the basis of the numbers that we are adding will not be the same. Here's an example. Evaluate 221 base 3 plus 2202 base 5 and give your answer in base 8. Now look at what we are supposed to handle here. We have 221 and it's in base 3. We have 2202 and it's in base 5. In the previous video, the two numbers we were adding were all in the same base. This time, this is in base 3 and this is in base 5. So we can't add them straight away. And even on top of that, we are supposed to give our answer in base 8, which is a totally different base. Now, whenever you have a question like this, you have two ways of doing it. So you are going to consider the first option and the second option. What is the first option? The first option is that you can convert 221 base 3 and 2202 base 5. You can convert both of them to base 8. Now, after you've converted this to base 8 and this to base 8, you can now add your answer. You can now add and get your results, your answer in base 8, right? So that is fairly simple. You convert this to base 8, you convert this to base 8, then you add them. After that, your answer will be in base 8. The other option, which is the second option, is that you can convert 221 base 3 and 2202 base 5 to base 10. You can convert this to base 10 and convert this to base 10. Then you add your answer. Now when you add them, you are going to get your answer in base 10. The question is telling us to give our answer in base 8. So after you have your answer in base 10, you can now convert it from base 10 to base 8. So you can pick any of these and you'll be able to do it. Now, for the sake of learning, we are going to pick them. You are going to do it for each of the options. You will see that our answers will be the same. After you've gone through the whole process, you can pick the option that is easy for you. So you pick the first option. The first option, we have to convert 221 base 3 and 2202 base 5 to base 8. So we begin by converting 221 base 3 to base 8. In one of the videos on number bases, we've learned how to convert a number from a non-decimal base to another non-decimal base. We know that in doing that, the first thing you need to do is to convert this, which is 221 base 3, to base 10. That's the first thing you need to do. So we are going to convert 221 base 3 to base 10. That is going to give us 2 times 3, 2 times 3, 1 times 3. Then you order them, so you have 0, 1, 2. So 2 times 3 squared is 9, 2 times 3 exponent 1 is 3, 1 times 3 exponent 0 is 1. So 2 times 9 will give us 18, 2 times 3 will give us 6, 1 times 1 will give us 1. So 18 plus 6 plus 1 will give us 25. So we have now converted 221 base 3 to base 10. We can now convert 25, which is the answer for this in base 10. We can now convert it to base 8. So we convert, so we have 221 base 3 to give us 25. This is in base 10, but we want it in base 8. So we convert 25 to base 8. So in converting 25 to base 8, we draw our table like this. We divide 25 by 8, and that will give us 3, a remainder of 1. We have solved a lot of this, so you should be conversant with how to find this. Now, since 3 is smaller than this, we write it here as our last number. So we can say that if you convert 25 to base 8, you get 3, 1 base 8. So you have here 3, 1 base 8. So we can say that 221 base 3 is now 3, 1 in base 8. So we have converted the first one to base 8. We move on to the second one. We convert 2202 base 5 to base 8. In doing that, you first have to convert 2202 base 5 to base 10. And that is going to give us 2 times 5, 2 times 5, 0 times 5, 2 times 5. Then you order them 0, 1, 2, and 3. So we are going to have 2 times 5 exponent 3 is 125. 2 times 5 exponent 2 is 25. 0 times 5 exponent 1 is 5. 2 times 5 exponent 0 is 1. So we have 2 times 125 will give us 250. 2 times 25 will give us 50. 0 times 5 will give us 0. Then 2 times 1 will give us 2. You add everything here and we are getting 302. So we can say that if you convert 2202 base 5 to base 10, you have a 302. But we don't want it in base 10. We want it in base 8. So we now convert 302 to base 8. If you convert 302 to base 8, first you divide 302 by 8. That will give us 37 and a remainder of 6. You divide 37 by 8 again, you are getting 4, a remainder of 5. Now since 4 is smaller than 8 here, you write it here as our last number. So we have 4, 5, 6. So if you convert 302 to base 8, you have 4, 5, 6 base 8. So we can say that if you convert 2202 base 5 to base 8, you have 4, 5, 6 base 8. So now we have converted 221 base 3 to base 8 and we are getting 31 base 8. We have also converted 2202 base 5 to base 8 and we have 4, 5, 6 to base 8. So we can now add this to this. So in adding that, we can say that 2213 plus 2201 base 3 plus 2202 base 5 will give us 31 base 8 plus 456 base 8. So we move forward to add. So we have 456 base 8 plus 31 base 8. So we are now doing the addition. Remember, we are working in base 8. So 6 plus 1 will give us 7. In base 8, we can write 7. So we write it there as 7. Now 5 plus 3 will give us 8. We are working in base 8, so we can't write 8. So 8 in base 8 will give us 1, remainder 0. If you divide 8 by 8, you get 1, remainder 0. So we write the remainder 0. We carry the 1 forward to this side. You add that 1 to 4 and you are getting 5. So 5 plus, there is no number here, which means that the number there is 0. So 5 plus 0 will give us 5. We are working in base 8, so we indicate it as 8. So you have seen that we have now converted this to base 8, we've converted this to base 8, and we have added it. So we can say that therefore 2213 plus 2202 base 5 will give us 507 base 8. This is the first option. Let's look at the second option. The second option is that convert both 2213 and 2202, 221 base 3 and 2202 base 5 to base 10. You add the results to get your answer in base 10. Now you convert it from base 10 to base 8. You have already seen how to convert this to base 10 in this video, and when you do that conversion, we are getting 25. So if you convert 2213 to base 10, you get 25. Next, you convert 2202 base 5 to base 3 to base 10. If you do that, we have already done that, and we got 302. So we can say that if you convert 2205 base 3 base 5 to base 10, we are getting 302. So we have now done that. So we now have 221 base 3 in base 10, which is 25. We have 2202 base 5 in base 10, and that is 302. So we can add them. Addition in base 10 is fairly simple, so we can do this. 25 plus 302 is in base 10, and that will give us 327. So we now have our answer here in base 10, but we don't want it in base 10, we want it in base 8. So we can now convert this to base 8. So we now convert 327 to base 8. And in converting it in base 8, we draw our table. You divide 327 by 8, you get 40, remainder 7. You divide 40 by 8, you get 5, remainder 0. Now since 5 is smaller than the number here, you write it here as the last digit. So that will give us 507 in base 8. So 327 will give us, in base 10 will give us 507 base 8. So we can say that therefore 221 base 3 plus 2202 base 5 will give us 507 base 8. So you can see that both of them are giving us the same results. Now you can try your hands on other examples and pick the option that is easiest to you. So you can either pick the first option or the second option, and each of them will give you the same results. Thank you for watching this video. Pick your more examples and try your hands on them so that you will be conversant with how this is done. In the next video, we are going to learn how to multiply and divide numbers that are in non-decimal basis. Bye-bye. We are on the topic number basis. In the previous video, we learned how to add and subtract numbers in non-decimal basis. In this video, we are going to learn how to multiply and divide numbers in non-decimal basis. So let's pick some examples and see how this is done. So the question is telling us to evaluate the following, and we have been given 4 questions here. So we pick them one after the other and see how to go about it. So we pick the first question. We have 100,110 base 2 times 11 base 2. So just as you do for multiplication in base 10, you arrange the number such that you can multiply it. So usually we write the number with the large digit first, then we followed by the number with the lesser digit. So in this case, we write this one first, then followed by this. We bring our multiplication sign here, then we draw the line such that we can multiply. So first, you are going to follow the same principles as multiplication for base 10. So 1 will multiply 0, we are going to get 0. 0 in base 2 is 0, so you write 0. 1 times 1 will give us 1. 1 in base 2 is 1. 1 times 1 again will give us 1. 1 in base 2 is 1. 1 times 0 is 0. 0 in base 2 is 0. 1 times 0 will be 0. 0 in base 2 is 0. Then 1 times 1 will give us 1. 1 in base 2 is 1. Then we multiply with this digit 2. So 1 times 0 will give us 0. 1 times 1 will be 1. 1 times 1 again will be 1. 1 times 0 will be 0. 1 times 0 is 0. Then 1 times 1 will give us 1. So we are done with the multiplication. So from here we have to add the two numbers that we have here. So we add 100,1102, 100,110. So we do the addition. Don't forget that the addition is in base 2. So we have 0 plus, there is no number here, so it means that the number there is 0. So 0 plus 0 will give us 0, in base 2 will be 0. Then 1 plus 0 will give us 1, 1 in base 2 is 1. 1 plus 1 will give us 2. 2 in base 2 is 1 remainder 0. So we write the remainder, which is 0. Then we carry the 1 forward to the side. So we bring that 1 here. So we are going to have 1 plus 1, which is 2. 2 in base 2 is 0. Is 1 remainder 0. So we write the remainder here, which is 0. Then we carry the 1 forward to this side. When you carry the 1 forward to this side, here is 0. So if you carry the 1 forward here, this place is going to be 1, since you are going to have 1 plus 0. So you are going to have 1 plus this 0 here, and that is going to give us 1. So this place is going to give us 1. So you can see from here that 1 plus 1 is 2. 2 remainder, 2 in base 2 give us 0 remainder 1. So you write, you give us 1 remainder 0. So you write the remainder 0. You carry the 1 forward to this side. You add it to this 0. You are going to get 1. So 1 plus 1 again give us 2. 2 in base 2 is 1 remainder 0. So you write the remainder 0. You carry the 1 forward to this side. Here is already 0. So 1 plus this 0 here will give us 1. So we have 1 plus 0, which will give us 1. 1 in base 2 is 1. Now we come here, 1 plus 0 will give us 1. So 1 in base 2 is 1. Then we already have 1 here, so 1. Don't forget that we are doing the addition in base 2. So it means that if you multiply 100,110 by base 2 by 1 1 base 2, we are going to have 1 1 1 0 0 1 0 base 2. Once again, you can use the trick I showed you in the previous video to try this on your calculator, since it's in base 2, and you can do that. If you are having problem following this, there is another alternative to this. All you need to do is to convert this number here to base 10. So convert 1 0 0 1 1 0 base 2 to base 10. Convert 1 1 base 2 to base 10. Multiply the answer that you get. You are going to get your answer in base 10. Then convert that final answer to base 2. It is that simple. They are all going to give you the same answer. Let's pick the next example. So we can say that if you have 1 0 0 1 1 0 base 2 times 1 1 base 2, you are going to have 1 1 1 0 0 1 0 base 2. The next example is 4 2 3 base 5 times 2 2 base 5. So we arrange them such that we can multiply. So we begin. 2 times 3 will give us 6. 6 in base 5 is 1 remainder 1. So you write 1, then you carry the 1 forward to the side. Now remember that we are doing multiplication, so you don't straight away add the 1 to this. You first multiply 2 by 2, that will give us 4. We already have a remainder 1, so you add that 1 to it. If you add that 1 to it, you are going to get 5. Now 5 in base 5 is 1 remainder 0. So you write 0, then you carry the 1 forward. Now when you come here, you are going to have 2 times 4, which will give us 8. Don't forget that we already have 1 that we've carried forward. So 2 times 4 will give us 8, plus that 1 will give us 9. 9 in base 5 will give us 1 remainder 4. So if 9 in base 5 will give us 1 remainder 4. So you write 1, then remainder 4, as we have here. So I'm going to go through it again. 2 times 3 will give us 6. 6 in base 5 is 1 remainder 1. So you write the remainder 1, then you carry the 1 forward to the side. But since we are doing multiplication, you first have to multiply before you add the remainder to it. So 2 times 2 will give us 4. We have a remainder 1, so you add that remainder 1 to it, it's going to give us 5. 5 in base 5 is 1 remainder 0. So you write 0 as the remainder, you carry the 1 forward. Now 2 times 4 will give us 8. You already have a remainder which is 1, you add that to 8, you are going to get 9. 9 in base 5 is going to give us 1 remainder 4, as we have it here. Now we are done multiplying with this, so you pick this one. So we are going to go through the same process again. 2 times 3 will give us 6. 6 in base 5 will give us 1 remainder 1. So you write 1, you carry the 1 forward. 2 times 2 will give us 4. You add 4 to 1, which is the remainder. You are going to have 5. 5 in base 5 is 0, 1 remainder 0. So you write the remainder 0, you carry the 1 forward. Now 2 times 4 will give us 8, plus that 1 will give us 9. 9 in base 5 will give us 1 remainder 4. So you can see from here that you use 2 to multiply this, so you are going to get this. In the same way, you use 2 to multiply the same thing, so you are going to, what is on top here is going to be the same as what is below here, just that their position will change, since this is here and this 2 is also at the side. So from here we can now add what we have here. So we have 1 plus, there is no number here, which means that is 0. So 1 plus 0 will give us 1. 1 in base 5 is 1. 0 plus 1 will give us 1. 1 in base 5 is 1. 4 plus 0 will give us 4. 4 in base 5 is 4. 1 plus 4 will give us 5. 5 in base 5 is 1 remainder 0. So you write the remainder 0, you carry the 1 forward to the side. We add that 1 to this, which is already 1. So 1 plus 1 will give us 2. And we are doing the addition in base 5. So it means that if you multiply, it means that if you multiply 423 base 5 by 22 base 5. You're going to have 420411 base 5. Once again, if you are finding it difficult following how this multiplication and addition is done, just convert 423 base 5 to base 10, convert 22 base 5 to base 10, then multiply the answers. You are going to get your answer in base 10. Then you convert that answer from base 10 to base 5, and it's going to be the same as what you have here. Let's pick the next example. We have 2402 base 5 divided by 13 base 5. So in division, what you have to do is that convert this to base 10, convert this to base 10, divide the result that you get, then finally convert your answer to base 5. That's simple. So you first convert 2402 base 5 to base 10. So in converting it, we know that you multiply each digit with the base. So 2 times 5, 4 times 5, 0 times 5, then 2 times 5. You order them, so 0, 1, 2, 3. We've done a lot of this, so you should be conversant with this process by now. So we are going to have 2 times 125 plus 4 times 25 plus 0 times 5 plus 2 times 1. 2 times 125 will give us 250, 4 times 25 will give us 100, 0 times 5 will give us 0, and 2 times 1 will give us 2. You add everything here and you are going to get 352. So we can say that if you convert 2402 base 5 to base 10, you are going to have 352. Then you now convert 13 to base 5. So in converting 13 to base 5, you are going to have 1 times 5 exponent 1 plus 3 times 5 exponent 0. So you multiply 1 with 5, you multiply 3 with 5. Then we order the bases, so 0, 1. Now this is going to give us 1 times 5 plus 3 times 1, and you add everything, you are going to get 8. So we can see clearly from here that 2402 base 5 in base 10 is 352. 13 base 5 in base 10 is 8. So we can divide this here. Remember, this division is done in base 10, so it's pretty easy. So 352 divided by 8 is 44. You can do this on a calculator since it's already in base 10. So you just punch 352 divided by 8. So it means that we now have our answer in base 10. 2402 base 5 divided by 13 base 5. We have it in base 10 to be 44. But we don't want our answer in base 10. The question gave us the numbers in base 5. So we have to represent our answer in base 5. So we have to convert 44 to base 5. So in converting 44 to base 5, you draw your table as usual. You divide 44 by 5. You are going to have 8, remainder 4. You divide 8 by 5. You are going to have 1, remainder 3. Now, since 1 is less than the number here, you write it as the last number here. So 134, which means that if you convert 44 to base 5, you're going to have 134 base 5. So we can now say that 2402 base 5 divided by 13 base 5 will give us 134 base 5. Let's move on to the last example. 20211 base 3 divided by 22 base 3. So what you need to do is to first convert the first number to base 10. Converting that, we have 2 times 3 exponent 4 plus 0 times 3 exponent 3 plus 2 times 3 exponent 2 plus 1 times 3 exponent 1 plus 1 times 3 exponent 0. This is going to give us 2 times 81, since 3 exponent 4 is 81, 0 times 27, 3 exponent 3 is 27, plus 2 times 9, 3 squared is 9, plus 1 times 3 exponent 1 is 3, plus 1 times 1, 3 exponent 0 is 1. Any number exponent 0 is 1. So we now have 2 times 81 will give us 162. 0 times 27 will give us 0, since any number times 0 is 0. 2 times 9 will give us 18. plus 1 times 3 will give us 3. Any number times 1 is the same number. 1 times 1 will give us 1. So we add everything here and we are getting 184. Now you convert 2 base 3 to base 10. That is the next step, and that is going to give us 2 times 3 exponent 1 plus 2 times 3 exponent 0. And this is going to give us 2 times 3 plus 2 times 1. 2 times 3 is 6, 2 times 1 is 2, 6 plus 2 will give us 8. So we now know that 20211 base 3 is 184 base 10. Then 22 base 3 is 8 in base 10. So we can divide this since they are already in base 10. 184 divided by 8, if you punch that on your calculator, you are going to get 23. So it means that now we have our answer in base 10, but we don't need the answer in base 10. We need it in base 3 since the question was in base 3. So we have to convert 23 to base 10. So in converting 23 to base 10, you draw your table like this. We divide 23 by 3, and that will give us 7, remainder 2. Since 23 divided by 3 will give us 7, 3 times 7 will give us 21. 23 minus 21 will give us the remainder 2. We have done a lot of this, so you should be conversant with how to find the remainders by now. Then the next step, you divide 7 by 3, and that's going to give us 2, remainder 1. Since 7 divided by 3 will give us 2, remainder 1 here. 3 times 2 will give us 6. 7 minus 6 will give us the remainder of 1. Now, since 2 is lesser than the number here, you are going to write it here as the last number. So you are going to have 2, 1, 2. So it means that if you convert 23 to base 3, you are going to have 2, 1, 2 base 3. So we can say that 20211 base 3 divided by 22 base 3 is equal to 212 base 3. So you see, it's pretty easy. When we are given two numbers to divide, all you need to do is first convert the first number to base 10, convert the second number to base 10, then you do the division in base 10. After that, you convert your answer from base 10 to the base that you were given. Thank you very much for watching this video. See you in the next video, where we'll take more examples on division and multiplication of numbers in non-decimal basis. This time, in the examples that we will pick, the two bases will be different. Bye-bye. We are still on the topic number basis. In the previous video, we learned how to multiply and divide numbers given in non-decimal basis. In this video, we are going to pick another example on multiplication and division of numbers in non-decimal basis. The examples that we'll be picking in this video is quite different. If you look at this very carefully, you will see that in the previous video, the two numbers that we are multiplying were in the same base. But in this video, the two numbers that are multiplying here are in different bases. So the question is telling us to evaluate this, leaving our answer in base 3. So for here, we have 101 base 2 times 23 base 5. And we are supposed to do this multiplication and we leave our answer in base 3. We also have 10066 base 8 divided by 12 base 8. But we are supposed to leave our answer in base 3, not base 8. So let's see how this is done. Let's begin with the first one. We are supposed to evaluate 101 base 2 times 23 base 5, and we leave our answer in base 3. Whenever you have something like this, you have two options to go by. The first option is that you can convert both 101 base 2 and 23 base 5 to base 3. Then we multiply to get our answer in base 3. That is the first option. You can also choose to, the second option is that you can choose to convert both 101 base 2 and 23 base 5 to base 10. Then you multiply and get your answer in base 10. Then from there, you convert that answer to base 3. Let's begin with the first option and see how this is done. So in the first option, we have to convert both 101 base 2 and 23 base 5 to base 3. So we begin by converting 101 base 2 to base 3. You know that to convert 101 base 2 to base 3, you first have to convert 101 base 2 to base 10. So converting 101 base 2 to base 10, we are going to have 1 times 2 squared plus 0 times 2 exponent 1 plus 1 times 2 exponent 0. We have done a lot of these conversions, so I assume that you are conversant with it by now. We have 1 times 4 plus 0 times 2 plus 1 times 1. That will give us 4 plus 0 plus 1, and that is going to give us 5. So if you convert 101 base 2 to base 5 to base 10, we are going to have 5. But we don't want to convert it to base 10. We actually want to convert it to base 3. So it means that we have to convert 5 to base 3. So if you draw your table, we are converting 5 to base 3. So 5 divided by 3 will give us 1, remaining 2. Now, since 1 is smaller than the number here, you are going to write it as the last digit here. So 1. It means that if you convert 5 from base 10 to base 3, it is 1, 2. So 1, 2 base 3. Now, we can see from here that 101 base 2 is actually 1, 2 base 3. Since 5 is also the same as 101 base 2. So we have now converted 101 base 2 to base 3. Next, we have to convert 23 base 5 to base 3. To convert 23 base 5 to base 3, we first have to convert 23 base 5 to base 10. So in converting it to base 10, we are going to have 2 times 5 exponent 1 plus 3 times 5 exponent 0. So 2 times 5 exponent 1 will give us 2 times 5, plus 3 times 5 exponent 0 will give us 3 times 1. We are going to have 10 plus 3, and that will give us 13. So if you convert 23 base 5 to base 10, you get 13. But we don't want it in base 10. We want it in base 3. So we have to convert 13 to base 3. So in converting 13 to base 3, you divide 13 by 3. That will give us 4, remainder 1. You divide 4 by 3, it will give us 1, remainder 1. Now, since 1 is less than the number here, you write it at the last digit here. So 13 base 3 will give us 1, 1, 1. 13 in base 10 will give us 1, 1, 1 in base 3. So we can say that 2, 3 base 5 is actually 1, 1, 1 base 3. So we now have 101 base 2 in base 3. We have it in base 3. We have 2, 3 base 5 also in base 3 to be 1, 1, 1 base 3. So 101 base 2 times 2, 3 base 5 is actually 1, 2 base 3 times 1, 1, 1 base 3. So we now have all of them in the same base. So we can use the technique we used in the previous video to multiply numbers in different bases. We can use that technique here to multiply these two. So to multiply them, we arrange them in this way. We have our multiplication sign here. Then we draw the line to begin the multiplication. So we have 2 times 1 will give us 2. 2 in base 3 is 2. 2 times 1 will give us 2 again. 2 times 1 will give us 2. Now 1 times 1 will give us 1. 1 times 1 will give us 1. Then 1 times 1 will give us 1. So we can now add what we have here. 2 plus, there is no number here, which means that is 0. So 2 plus 0 will give us 2. 2 in base 3 will give us 2. 2 plus 1 will give us 3. 3 in base 3 is 1, remainder 0. So you write the remainder 0, we carry the 1 forward to this side. If you carry the 1 forward to this side, we add that 1 to what we have here, which is already 2. We are going to get 3. So we have 3 plus 1. 3 plus 1 will give us 4. 4 in base 3 is 1, remainder 1. So we write the remainder 1, then we carry the 1 forward to this side. You add that 1 to what we have here, which is already 1, and we are going to get 2. Remember that we are working in base 3, so you indicate the base as base 3, which means that if you multiply 101 base 2 by 23 base 5, you are going to have 2102 base 3. So therefore 101 base 2 times 23 base 5 give us 2102 base 3. So this is the first option. Let's look at the second option. In the second option, we convert 101 base 2 and 23 base 5. You convert both of them to base 10. We have already done that, and when we converted 101 base 2 to base 10, we had 5. The next thing is to convert 23 to base 10. So if you convert 23 base 5 to base 10, you are going to have 13. We did that and we got 13. Now remember that in an examination, you don't have to do all the two options. I'm showing you the two options so that you can pick the one that you are comfortable working with. So we have converted 23 base 5 also to base 10. So it means that we can do the multiplication, because 101 base 2 is 5 in base 10. 23 base 5 is 13 in base 10. So we can do 5 times 13. These are all in base 10. So multiplication in base 10 is fairly simple. So 5 times 13 will give us 65. So we now have the answer here, but it's in base 10. The question told us to leave our answer in base 3. So we have to convert 65 to base 3. So we now convert 65 to base 3. 65 divided by 3 will give us 21, remainder 2. 21 divided by 3 will give us 7, remainder 0. 7 divided by 3 will give us 2, remainder 1. Now since the number here is less than what we have here, we write it here as our last digit. So that will give us 2102. So we can say that 65, if we convert it to base 3, we are going to have 2102 base 3. So 101 base 2 times 23 base 5 give us 2102 base 3. So with these two options, you study them and you pick the one that you are comfortable with. It looks like the second option is pretty simple and short, so you can pick that one. But if you are comfortable with the first one, you can also use that. Let's look at the second example. We are told to evaluate 10066 base 8 divided by 12 base 8 and leave our answer in base 3. So what we have to do is that first convert this to base 8. So we convert this from base 8 to base 10 since we are doing division. So if you convert 10066 base 8 to base 10, you're going to have 1 times 8 exponent 4 plus 0 times 8 exponent 3 plus 0 times 8 exponent 2 plus 6 times 8 exponent 1 plus 6 times 8 exponent 0. This is going to give us 1 times 4096 plus 0 times 512 plus 0 times 64 plus 6 times 8 plus 6 times 1. You do all this calculation, you're going to have 4096 plus 0 plus 0 plus 48 plus 6, and that is going to give us 4150. So we have converted 10066 base 8. We have converted that to base 10, and we are having 4150. So we now convert 12 to base 10. So converting 12 to base 10, we have 1 times 8 exponent 1 plus 2 times 8 exponent 0. That will give us 1 times 8 plus 2 times 1, and that is going to give us 8 plus 2, which is 10. So we can say that 10066 base 8 divided by 12 base 8 will give us 4150 divided by 10. 4150 divided by 10 will give us 415. Remember, the question said we should leave our answer in base 3, not base 10. So we have to convert 415 to base 3. So converting 415 to base 3, you draw your table as usual. 415 divided by 3 will give us 138, remainder 1. 138 divided by 3 will give us 46 remainder 0. 46 divided by 3 will give us 15 remainder 1. 15 divided by 3 will give us 5 remainder 0. 5 divided by 3 will give us 1 remainder 2. Now since we have 1 here which is less than the base we are converting to, which is base 3, you write it here as our last digit. So we can say that if you convert 415 from base 10 to base 3, you are getting 1201101 base 3. So we can say therefore 10066 base 8 divided by 12 base 8 is actually 120101 base 3. Thank you for watching this video on division and multiplication of numbers in non-decimal basis. To help you understand this very well, pick more examples and try your hands on them. If you have any problem, interact with me on my social media handles and I'll help you to solve the questions. In the next video, we are going to see how we can draw tables for a given operation in a given number base. Bye-bye. We are still on the topic number basis. In the previous video, we learned how to multiply and divide numbers that are in non-decimal basis. In this video, we are going to learn how to draw a table for a given operation in a given base. Now this is what I mean. The operations that we'll be considering are addition, subtraction, multiplication, and division. So sometimes you can be told to draw a table, maybe draw an addition table for a given operation. Let's say draw an addition table in base 3. We are going to pick examples to see how this is done. So let's begin by looking at this example. We have two questions here. The first question says that we should draw addition and multiplication tables for base 5. In the second question, we have been given a binary addition and multiplication table and we are being told to complete it. Remember that binary means base 2. So it means that this table is in base 2 and we have to complete it. Let's begin with the first one. So we are being told to draw addition table and multiplication table for base 5. So we begin by drawing the addition table. Now since we know that in base 5, the digits that we can use in base 5 are 0, 1, 2, 3. Oh, sorry, I have to write 3 more. So in base 5, the digits we can use are 0, 1, 2, 3, and 4. So these are the digits that we can use in base 5. Now since you are being told to draw addition tables for base 5 and no different set was specified for us, you have to use these digits in drawing the table. So we first draw a table like this. We have the addition sign here. We usually draw a circle around the addition sign. So we have the addition sign here. Then we have the digits that you can use in that particular base. So in this case, in base 5, you can use 0, 1, 2, 3, 4. So we have 0, 1, 2, 3, 4 here. Then 0, 1, 2, 3, 4 here. So if we are told to draw the table for base 7, then it means that we are going to use the digits 0, 1, 2, 3, 4, 5, 6. If we are being told to draw for, let's say, base 6, it's going to be 0, 1, 2, 3, 4, 5. But this time we are being asked to draw for addition in base 5. So the digits we can use are 0, 1, 2, 3, 4. So we have it here. So from here, you do the addition. Now this is how it's done. It's going to be like this. You pick the first one here, you add it to everything here. You pick the next one, you add it to everything here, then you write it here. You pick the next one here, you add it to everything, you write it there. Just as you do when you are filling a table. So the first one is 0 plus 0. 0 plus 0 is 0. 0 in base 5 is 0. So 0 plus 1 is 1. 1 in base 5 is 1. 0 plus 2 is 2. 0 plus 3 is 3. 0 plus 4 is 4. Remember that we are working in base 5. 1 plus 0 is 1. 1 in base 5 is 1. 1 plus 1 is 2. 2 in base 5 is 2. 1 plus 2 is 3. 1 plus 3 is 4. 1 plus 4 is 5. Now we know that 5 in base 5 is 1 remainder 0. So 1 remainder 0. Now I hope that is clear. We move on. 2 plus 0 is 2. 2 plus 1 is 3. 2 plus 2 is 4. 2 plus 3 is 5. 5 in base 5 is 1 remainder 0. 2 plus 4 is 6. 6 in base 5 is 1 remainder 1. Then we come here. 2 plus 3 plus 0 is 3. 3 plus 1 is 4. 3 plus 2 is 5. 5 in base 5 is 1 remainder 0. 3 plus 3 is 6. 6 in base 5 is 1 remainder 1. 3 plus 4 is 7. 7 in base 5 is 1 remainder 2. Now we come here. 4 plus 0 is 4. 4 plus 1 is 5. 5 in base 5 is 1 remainder 0. Then 4 plus 2 is 6. 6 in base 5 is 1 remainder 1. 4 plus 3 is 7. 7 in base 5 is 1 remainder 2. 4 plus 4, which is the last one, is 8. 8 in base 5 is 1 remainder 3. So this is how the addition is done. So you draw your table, then you perform the addition in the base that was given to you. So this is the addition table for base 5. Let's move on to the multiplication table for base 5. So once again, we have our multiplication sign here. You draw the circle around it. Then we have the digits that we can use in base 5, which is 0, 1, 2, 3, 4, 0, 1, 2, 3, 4 here. So we do the multiplication in the same way. So we begin with 0. 0 times 0 is 0. 0 times 1 is 0. 0 times 2 is 0. 0 times 3 is 0. 0 times 4 is 0. Any number multiplying 0 is 0. So when you come here, 1 times 0 is 1. 1 times 1 is 1. 1 times 2 is 2. 1 times 3 is 3. 1 times 4 is 4. We pick this one. 2 times 0 is 0. 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. 6 in base 5. Don't forget that we are still working in base 5. So 6 in base 5 is 1 remainder 1. Then 2 times 4 is 8. 8 in base 5 is 1 remainder 3. We come here. We have 3 times 0, which is 0. 3 times 1 is 3. 3 times 2 is 6. 6 in base 5 is 1 remainder 1. 3 times 3 will give us 9. 9 in base 5 is 1 remainder 4. Then 3 times 4 will give us 12. 12 in base 5 is 2 remainder 2. So you have that there. Now when you come here, we have 4 times 0. So 4 times 0 will give us 0. 4 times 1 will give us 4. 4 times 2 will give us 8. 8 in base 5 is 1 remainder 3. 4 times 3 will give us 12. 12 in base 5 is 2 remainder 2. Since 5 times 2 will give us 10, then 12 minus 10 is 2. So we have 2 remainder 2. 4 times 4 will give us 16. Then 16 in base 5 is 3 remainder 1. Since 5 will divide 16 3 times, remainder 1, as we have it here. So you multiply, then you write your answer in the base that was given to you. It's very simple, right? Let's move on to the next one. So you are being told to complete the binary addition and multiplication table below. So we have this one as binary. Remember, whenever you see binary, it means base 2. So we are doing this addition in base 2. So just as we did when we were doing addition in number bases, all you need to do here is in this column or in this particular box, you are going to have 1 1 plus 1 1. You write the answer here. 1 1 plus 1 0 1. You write the answer here. 1 1 plus 1 0 0 1. You write the answer here. Then you pick this 1 0 1 plus 1 1. You write it here. 1 0 1 plus 1 0 1. You write it here. 1 0 1 plus 1 0 0 1. You write it here. You do the same thing for this also. Now I'm going to show you how to use your calculator to do this. I entreat you to solve this on your own before trying the trick on the calculator. In the previous video, we've learned how to add numbers in base 2. So you should watch that video and see how this is done. But in this video, I'm going to use the calculator to teach you how to do this. So once again, I said if you want to do this addition on your calculator, you switch on your calculator first. Remember that our calculators will allow us to add in base 2, base 6, base 10, and base 8. Luckily for us, this is in base 2, so we can perform this addition in base 2. So you take your calculator, then you press on mode, you pick 4, which is base. It's already in base 10, which is dec. You click on the log sign. You see on that you have BIN, that means binary base 2. So you have that. So we can now do our addition. So first we want 1 1 plus 1 1. So 1 1 plus 1 1, and you are getting, ignore the first 0. So you pick the first one here. So 1 1 0. It means that in this place the first one is 1 1 0. The next one is 1 1 plus 1 0 1. So our calculator is still on base 2. So 1 1 plus 1 0 1, and that will give us, ignore the zeros, start picking from the first one. So we have 1 0 0 0. So it means that in this case you are going to have 1 0 0 0. The next one is 1 1 plus 1 0 0 1. So we have 1 1 plus 1 0 0 1, and that will give us 1 1 0 0. So here you are going to have 1 1 0 0. Once again, try this with your hands and see how this is done, because in an examination you have to show working. You can't use the calculator, this calculator trick, in doing for maybe a theory question. If it's an objective, maybe you don't have to show the working, but in a theory you have to show working. So try this with your hands. In previous videos we've studied how to add this. In this video I'm just using the calculator to show you how to do the addition also. So with this side you have 1 0 1 plus 1 1 to fill here. So you punch that on your calculator. You have 1 0 1 plus 1 1, and that will give us 1 0 0 1. So 1 0 0 1. Then 1 0 1 plus 1 0 1. So on the calculator we have 1 0 1 plus 1 0 1, and we have 1 0 1 0. So 1 0 1 0. Now in this box we are going to have 1 0 1 plus 1 0 0 1. So 1 0 1 plus 1 0 0 1. So we have 1 1 1 0. So 1 1 1 0. Then we come here, it's going to give us 1 0 1 plus 1 1. If you try that on your calculator, you are going to have 1 1 0 0. Then 1 0 0 1 plus 1 0 1. You try that, you're going to have 1 1 1 0. 101 plus 101, you should try that on calculator. 1001 plus 1001, we are having 10010. So you have 10010. So once again, try working this on your own using the technique that we learned in the previous video. Then from there, you verify your answer, or you cross-check your answer with what you have on the calculator. You've completed for the addition table. Let's look at the multiplication table. So it follows the same principle, just that in this case we are doing multiplication instead of addition. So in this first box, we are going to have 1 times 1. So we get 1001 here. So 1001. Then we are going to have 1 times 101. So 1 times 101, and that will give us 1111. So 1111. So if you do 1 times 1001 here, you are going to have 11011. We have here 101 times 11 give us 1111. 101 times 101 will give us 11001. 101 times 1001 will give us 101101. Then 1001 times 11 will give us 11011. 1001 times 101 will give us 101101. Then lastly, 1001 times 1001 will give 101001. Once again, in previous videos, we've studied how to multiply numbers in non-decimal basis. So you can watch that video and you will see how to multiply 11 by 11, how to multiply 11 by 1001. After you've done that, you can cross-check your answer with what we have on the calculator here. Don't forget that after doing all this on your calculator is always going to be in base 2. So if you want to change it from there and perform normal calculations as you have been doing, you have to clear your calculator. So you press shift 9. So you press on shift, then press on 9 to ask you clear. You select 3. So you select 3 to clear everything. So we now have our calculator there. Thank you for watching this video on drawing tables for a given operation in a given number base. See you in the next video, where we will take another examples on drawing table for a given operation in a given number base. This time we are going to take other questions attached to the table. Bye bye. We are still on the topic number bases. In the previous video, we studied how to draw tables for a given operation in a given number base. In this video, we are going to take yet another example on drawing tables for a given operation in a given number base. Now let's look at the question that we are tackling in this video. We are being told to draw addition table for base 8 on the set 1357. Then use your table to solve I. 3 plus x is equal to 12, x plus x is equal to 6. Now this is quite different from what we saw in the previous example. In the previous video, we were told to draw addition table for base 5. There was no set given to us. This time we are drawing addition table for base 8, but a set has been given to us, which means that we have to use the set that has been given to us. So if the set was not given to us, the numbers we are going to use will be 0, 1, 2, 3, 4, 5, 6, 7, since it's in base 8. But this time the set has been given to us, so we can't pick our own set. We have to use the set that the question gave to us. So in drawing the table, This will be the numbers in the table. 1357, 1357 is addition, so you bring your addition sign here. So we can see from here that the set gave us 1357, so we have to use the set. The question gave us 1357, so we have to use the set that the question gave us. If this set had not been there and the question tells us to draw addition table for base 8, then the set you will use will be 0, 1, 2, 3, 4, 5, 6, 7. But this time the question is telling us to draw the table on the set 1357, so we have to use the set that the question gave us. Don't forget that the addition is still in base 8. So we begin to do our addition. 1 plus 1 is 2. 2 in base 8 is 2. 1 plus 3 is 4. 4 in base 8 is 4. 1 plus 5 is 6. 6 in base 8 is 6. 1 plus 7 is 8. 8 in base 8 is 1 remainder, 0. 3 plus 1 is 3. 3 plus 1 is 4. 4 in base 8 is 4. 3 plus 3 is 6. 6 in base 8 is 6. 3 plus 5 is 8. 8 in base 8 is 1 remainder, 0. 3 plus 7 is 10. 10 in base 8 is 1 remainder, 2. Then we come to this side. 5 plus 1 is 5. 5 plus 1 is 6. 6 in base 8 is 6. 5 plus 3 is 8. 8 in base 8 is 1 remainder, 0. 5 plus 5 is 10. 10 in base 8 is 1 remainder, 2. 5 plus 7 is 12. 12 in base 8 is 1 remainder, 4. 7 plus 1 is 8. 8 in base 8 is 1 remainder, 0. 7 plus 3 is 10. 10 in base 8 is 1 remainder, 2. 7 plus 5 is 12. 12 in base 8 is 1 remainder, 4. Then 7 plus 7 is 14. 14 in base 8 is 1 remainder, 16, as we have it here. So we have now drawn the table. We've now drawn the table. Let's move on to solve the question that was given to us. The second question says that we should use our table to find I. 3 plus x is equal to 12. Now, whenever you are being told to use your table to find for this, what you have to do is that you have to try x for all the values that was given to you. So you have to try when x is equal to 1, when x is equal to 3, when x is equal to 5, and when x is equal to 7. You try x for all the values in the set that was given to you. So first, when x is equal to 1, we know that when x is equal to 1, this whole thing will change to 3 plus 1. From the equation says that 3 plus 1 to give us 12. So what we have to do is that we now have to find 3 plus 1 from our table and see if it is 1, 2. From our table, 3 plus 1 is 4. So you can see from here that 3 plus 1 is 4. But we know that 4 is not equal to 1, 2. So it means that x is not 1 is not the correct answer for x. So we move on to the next element in the set. The next element is 3. So you try for when x is equal to 3. When x is equal to 3, the equation will become 3 plus 3 is equal to 1, 2. So we have to check our table. What is 3 plus 3? From the table, 3 plus 3 is 6. Once again, we know that 6 is not equal to 12. So we can say 6 is not equal to 12, which means that x is not 3. So we continue. You try for when x is equal to 5. When x is equal to 5, the equation will become 3 plus 5. Since now x is 5, so 3 plus 5 is equal to 1, 2, or 12. So you check. What is 3 plus 5? From the table, 3 plus 5 is 10. So if 3 plus 5 is 10, we can say that 10 is not equal to 12. So it means that we have to try for the last set, which for the last element of the set, which is 7. So when x is equal to 7, the equation becomes 3 plus 7 is equal to 1, 2. So check from your table. 3 plus 7 is actually 1, 2, or 12 as we have here. So we can say that, therefore, x is equal to 7, since 7 is the only one that gives us, that makes the equation true, because 12 is equal to 12 as we have here. I hope that is clear. Let's move on. The next one says that we should find x such that x plus x will give us 6. So once again, you try for all the numbers in the set. So we pick the first one. When x is equal to 1. When x is equal to 1, we are going to have 1 plus 1 should give us 6. From our table, 1 plus 1 is 2, not 6, which means that s is not equal to 1. You try for the next one. When x is equal to 3, when x is equal to 3, we are going to have 3 plus 3 to give us 6. Now from the table, 3 plus 3 is actually 6, which means that x is equal to 3. That's correct. But when you have one to be correct, you don't have to end there. Sometimes others may also be correct. So you have to try for all the elements in the set. We have found that x is equal to 3 is correct. It satisfies it, since 6 will give us 6. But you don't have to end it, because some of the set elements in the set may also satisfy it, which means that in that case the answer will be 2. So if you find one, don't end there and assume that that is the only one. Others might also satisfy. So you have to try for all the elements in the set. So you try for the next element in the set, which is 5. So we say when x is equal to 5. When x is equal to 5, we are going to have 5 plus 5 to give us 6. From our table, 5 plus 5 is 1, 2, or 12 as we have here. So we can say that that is also not correct. So because 12 is not equal to 6. Then the last one, when x is equal to 7, we have 7 plus 7 to give us 6. Sorry, this is 6, not 16. So 7 plus 7 to give us 6. We check the table. What is 7 plus 7 will give us 16. So we can say that 16 is not equal to 6. So you will see that from here, when we check the whole thing, we saw that it is only x is equal to 3 that satisfies it. So we can see that therefore x is equal to 3 for the second part. I hope that is clear. Thank you for watching this video. Pick more examples on drawing tables for a given operation in a given number base. Try your hands on these examples. Solve more. Try your hands on them. If you have any problem, interact with me on my social media handles and I'll help you to understand them. See you in the next video, which will be the last video on number bases. In that video, we are going to learn how to solve equations involving number bases. Bye-bye. We are on the topic number bases. This is the last video on number bases. In the previous video, we learned how to draw tables for a given operation in a given number base. In this video, we are going to tackle number bases that involves equations or equations in number bases. So let's pick some examples. Equations involving number bases. So the question says that we should solve for x in the following. So we pick them one after the other and we solve it. Let's pick the first one. We are supposed to solve for x in 3 to x base 4 is equal to 56. So we are supposed to solve for x here. Now how do we go about this? You see that we have 56 here. There is no base attached to it, which means that it's in base 10. We have 3 to x base 4 here. So to solve them, they all must be in the same base. Now we have 56 in base 10. So we can easily convert 3 to x base 4 also to base 10. So we have 32x in base 4. We can convert that to base 10, then we equate it to 56, which is already in base 10, and we start solving from there. We know how to convert numbers from a given base to base 10. The x here doesn't change anything. It follows the same principle. We know that to convert a number to base 10, you have to multiply every digit in the number with the base. So you begin by, you multiply x 3 with 4, you multiply 2 with 4, you multiply x with 4. Then you order the bases. So 0, 1, 2. So you see, nothing changes. It's the same principles as we have been doing all along. We have 3 times 4 squared is 16 plus 2 times 4 exponent 1 is 4 plus x times 4 exponent 0 is 1. So we are going to have 3 times 16 will give us 48. 2 times 4 will give us 8. X times 1 will give us x. From algebra, we know that 48 plus 8 plus x will give us 56 plus x. Since 48 plus 8 will give us 56, then plus x. These are not like terms, so we have to leave them like this. If you watch the video on algebra, you know why this must be left like this. So we are going to have 56 plus x. So we now have 32x base 4 also in base 10. In base 10, we are going to have 56 plus x. This side is already in base 10, so we can equate this to that. So we say that we now know that 32x base 4 is the same as 56 in base 10. Now 32x base 4, if you convert that to base 10, we are going to have 56 plus 4. So this is 32x base 4 is 56. 32x base 4 is also 56 plus x. So we can equate this and that. So we can say that x plus 56 is equal to 56. Since it's the same 32x base 4, 32x base 4, so you can equate this and that. Now we solve this. This is a linear equation, so we solve it. We know that we have 56 here, we have 56 here, numbers, so we can group like terms. We group the x at one side, we group the numbers at one side. There is only one x here, so we are going to keep it here. 56 is here, we take it to the other side, it's positive. When you take it to this side, it's going to be negative. So we are going to have x is equal to 56 is positive here, so when it comes here, it becomes minus 56. So we say that x is equal to 0. So the x in this equation here is 0. So it means that 32x base 4 is actually 320 base 4, since we have found x to be 0. It's pretty simple, right? Let's pick the next example. 441 base x is equal to 121. Now remember, 121 is already in base 10. So what you have to do is now convert 441 base x to base 10. Once again, nothing changes. It's the same principles that we use. You know that to convert a number to base 10, what you have to do is that you first multiply the number with the base. So you first multiply 4 by x, and 1 by x. Then you order the bases. This time x is the base, so you order the x's. So you have 0, 1, and 2, just as we have been doing as usual. So this is going to give us 4 times s squared to give us, so it's going to be the same 4 times s squared plus 4 times x, s exponent 1 is the same as x, plus 1 times, now s exponent 0 is 1. Remember I said any number or variable exponent 0 is 1, so x exponent 0 is also 1. 4 times x will give us 4 times s squared will give us 4s squared, plus 4 times x will give us 4x, then plus 1 times 1 will give us 1. If you watch the video on indices, you will understand that 4s squared and 4x are not like terms, so we can't add them. So you leave this one like that. 4x squared plus 4x plus 1. So we have now converted this whole thing here to base 10, and we are having 4x squared plus 4x plus 1. This is already in base 10, so it means that we can equate this here and 121. So you say that 441 base x is equal to 121. 441 base x is also equal to 4x squared plus 4x plus 1. So we can equate these two. So we equate 4x squared plus 4x plus 1 to 121. So we group like terms. These are the x's, so we send the x's to one side, then we send the numbers also to the other side, or we group them at the same position. So we want to bring this one here. It looks like we are having a quadratic equation, so you write it in such a way that the quadratic equation will be clear for us to solve. So we bring 121 from this side, we bring it to this side here. It's positive, so when it comes here it becomes negative. So we are going to have 4x squared plus 4x plus 1 minus 121 is equal to 0. And this is going to give us 4x squared plus 4x minus 120 to give us 0. Now this is an example of a quadratic trinomial. In the videos on algebra, we dedicated a whole video into treating quadratic trinomials. If you watch that video, you will see how to solve this quadratic trinomial. Once again, I'm going to explain that in this video on the calculator for you to see. So I said that to find this, whenever you have a quadratic trinomial like this, you first have to identify your A, B, and C. So in this video, our A will be 4. Our A is 4. Then B is also 4. B is equal to 4. Okay. So B is also 4. Then C is equal to negative 120. So A is 4, B is 4, then C is also equal to negative 120. So I said that to find the two numbers that you use in expanding this trinomial, the first thing you need to do is after you've identified all this, you multiply your 4 by, you multiply your A by the C. So in this case, A is 4, C is negative 120. So if you multiply A by C, you are going to have, sorry for this, so 4 times 120, that will give us 480. Now since it's negative here, it means you are going to have negative 480. So if you multiply A by C, you are getting negative 4, then 80. So A by C is given as negative 480. Now you go ahead to use your calculator to find it. So you press on, then you go to mode, you pick equation 5, you pick the third one, then A is 4, B is 4, C is negative 120, then you press enter. Now the first answer is 5. We said that whenever you get your first answer, here is positive, so you pick it as negative. So you are going to pick it as negative 5. You multiply that with A. So if you multiply negative 5 with A, which is 4, you are going to get negative 20. It means that one of the numbers is negative 20. If you want the other number, divide the first number, which is negative 20, by your A times C. Our A times C is negative 480. So if you divide negative 480, so it means that you have to clear your calculator now. So you are clearing the calculator. If you divide negative 480 by negative 20, you are going to have 24, which means that the two numbers we are looking for are negative 20 and 24. Those are the two numbers that you will place 4x with. If this what we are doing here looks clumsy, watch the video on algebraic expression, on factorizing quadratic trinomials in algebraic expression, and you will understand what we are doing in this video. We dedicated a whole video on how to use our calculator to find those two numbers when we are factorizing quadratic trinomials. So the two numbers we are looking for are 24 and negative 20. So we replace 4x with 24x and negative 20x. So you're going to have 4x squared plus 24x minus 20x minus 120 is equal to 0. So we are factorizing. We can factorize 4x out. We are going to have x plus 6. Once again, if you watch the video on algebraic expressions, factorizing algebraic expressions, you understand how this factorization is done. Here, we can factorize 20 out. So you factorize 20 out, you are going to get x plus. Now, as I said in quadratic, in algebraic expressions, if you are factorizing and we have a negative sign outside the bracket, the sign inside the bracket must change. So the sign here was negative, it will change to positive. So plus 6 will give us x plus 6 will be equal to 0. So we now have x plus 6 in this bracket, x plus 6 in that bracket. So we pick one of them, then you pick the ones outside the bracket. So we have 4x minus 20 in one bracket, then x plus 6, you pick one of them, is equal to 0. Now we can see from here that we have 4x minus 20 in one bracket, then x plus 6 in another bracket, and they are all equal to 0. Remember that if you have two things being equal to 0, it's either the first one is 0 and the second one is not 0, or the first one is not 0 and the second one is 0, or both of them are 0. So here, in order to find x, we equate each one of them to 0. So we equate the first bracket to 0, we equate the second bracket to 0. So we pick the first bracket, we equate it to 0, such that we can find x. Now we have 4x minus 20 will be equal to 0. We take the bracket off since there is no number outside here to multiply. So we have 4x minus 20 to be equal to 0. Solving linear equations, we know that we have to bring the 20 to this side. 20 is negative. When it comes here, it becomes positive. Watch the video on solving linear equations and you see how this is done. So we divide both sides by 4. We divide here by 4. We divide here by 4. 4 will cancel itself. 4. So here we'll be left with x. 20 divided by 4 will give us 5. So we have our first x to be 5. Now we go to the second bracket. In the second bracket, we know that we have x plus 6 is equal to 0. If you take the brackets out, we have x plus 6 will be equal to 0. Then x to be equal to negative 6. So you see from here that we have two values for x. We have x to be equal to 5 and x to be equal to negative 6. Now, both of them can't be true. Only one of them will be true. Now, let's look at our question. In the question, x is a number base. Remember that it is 4, 4, 1 base x. So, x is a number base. Now, a number base must be a positive whole number. Since x is a number base, it must be a positive whole number. Number bases are not negative. We have not seen any negative number base here. So the number base must be a positive whole number. So you look here, we have 5. We look at this side, we have 5 and negative 6. So among 5 and negative 6, which one is a positive whole number? That is 5. So it means that x is 5. See, after solving, we got x to be 5 or negative 6. Both of them can't be true. It means that one is true. So we pick the one that satisfies the condition that we are working with. In the condition that we are working with, we are saying that x, the value we are looking for, must be a positive whole number since it is a number base. So in this case, x will be 5. Let's look at the next example. We have 2, 1, 1 base x is equal to 3, 4, 0, 3, 2, 0 base 4. So once again, we have this one here in base x, we have this one here in base 4. They must all be in the same base. So we convert this to base 10. We convert this one also to base 10. So in converting 2, 1, 1 base x to base 10, we use the same principles as we have been doing. So we have 2 times x plus 1 times x plus 1 times x. Then we order them, so 0, 1, 2. Remember this time, x is the base. So the powers will be given to the x's. So this is going to give us 2 times x squared plus 1 times x plus 1 times 1, since s exponent 0 is 1. So this will give us 2x plus x plus 1. So it means that we have converted this to base 10. If you watch the video on algebraic expressions, you will see that x squared, 2x squared, and x are not like terms, so you can't add them. So we leave our answer like this: 2x squared plus x plus 1. Now we have to convert this one also to base 10. So in converting 320 base 4 to base 10, we have 3 times 4 squared plus 2 times 4 exponent 1 plus 0 times 4 exponent 0. That will give us 3 times 16 plus 2 times 4 plus 0 times 1. 3 times 16 will give us 48. 2 times 4 will give us 8. 0 times 1 will give us 0. 48 plus 8 will give us 56. 56 plus 0 is still 56. So now we have converted 211x to base 10. We had 2x squared plus x plus 1. We have converted 320 base 4 to base 10. We had 56. So we can equate what we converted here and what we converted here. So if you equate them, you are going to have 2x squared plus x plus 1 is equal to 56. Now this is a quadratic equation, so you bring this here so that you can have equal to 0 here. So you are going to have 2x squared plus x plus 1 minus 56 is equal to 0. And this is going to give us 2x squared plus x minus 55 is equal to 0. Once again, if you watch the video on solving quadratic trinomials in the videos on algebraic expressions, you understand how to break this down. So in breaking this down, we are going to have 2x squared minus 10x plus 11x minus 55 is equal to 0. Watch the video on solving quadratic trinomials and you see how we got negative 10x and positive 11x here. If you are factorizing this out, if you watch the video on factorizing algebraic expressions, you see that this will give us 2x into bracket x minus 5 plus, so here we can factorize 11 out. We factorize 11, get x minus 5 is equal to 0 here. So we have x minus 5 here, x minus 5 here, so you pick one of them, then you pick what you have outside the bracket, so 2x plus 11 is equal to 0. So we solve them by equating each one of them is equal to 0. So you equate x minus 5 is equal to 0. You are going to have x minus 5 is equal to 0. Then x is equal to 5. Then we solve for the second bracket too. So we have 2x plus 11 is equal to 0. So in solving for linear equations, this is going to give us 11 is positive here. When it comes here, it becomes negative. So we're going to have negative 11 divided by 2 to give us x. If you watch the video on solving linear equations, you understand how x is negative 11 divided by 2. Because you bring 11 here, it becomes negative 11. You divide both sides by 2, so you're going to have x to be equal to negative 11 divided by 2. Now once again, what is x? X is the base of a number, or a number base. S is a number base. Number bases are positive whole numbers. In this case, S is giving us 5 or negative 11 over 2. So to find x is a positive whole number since it is a number base. So we can say that x is equal to 5 since it is a positive whole number. Thank you for watching this video and all the videos on number bases.